Alright, my friends, now copy begins with what is an API, of course, because I think that while it's important that you all have the basis, we need to go over everything so it is concrete and in one place. I think you should all know this. Nothing that I'm gonna say here should be new to you, but let's start anyway. First of all, what is an API? An API is an application programming interface. When two apps are going to have to communicate with each other, they can use what's known as an API, application programming interface, two programs interfacing with each other. This can be on different levels, which is important to realize because we're talking about applications here that are interfacing with each other, which is not always the case, of course. It's also sometimes on web level, on OS level. We'll be focusing mostly on web APIs in this course because I think that is where we should be putting our attention at the beginning. There are more APIs that we could look into, but by far there are more websites than other APIs out there, so we'll get started with that. I think it's important to realize that an API, of course, what often happens is that APIs to applications, if they're going to communicate with each other, they're going to trust each other. There's that inherent trust relationship, and that's something that we can often take advantage of because it's often not suspected that an API is becoming an attack surface, but more and more we are starting to see that. The more these APIs are becoming important, the more we need to learn how to hack them, of course, because guess what? The black hats aren't just sitting still either. Of course, you're not one of those black hats, you're a white hat, I know it for sure. Now, what types of APIs can we have? First of all, the web APIs that we'll look mostly at can consist of different types of APIs. REST and SOAP are often compared. In my opinion, it's like comparing an apple to a banana. Not really the same thing, but fine. GraphQL, it's architectures, that's what it's about. Then you also have database URLs, APIs, URLs, Jesus, operating system APIs, library and framework APIs, and so much more. How an API works, at least on web level, from now on in this course, if we say an API, you can assume that we're talking about a web API. They basically work on the request and response model. Now, where do you know that from? From your browser, from your website, indeed. So you also have those HTTP methods that you're used to. Get, post, put, options, delete. It works based on those, but they are pretty much baked into a website, to the web. An API, I can define myself which of these methods are allowed and which ones aren't. It's basically, I can determine what I'm going to allow and return as well in terms of status code. So if you submit a certain string and I don't like it, I can give you a 500 server error, for example, back. That can happen over a GET request, over a POST request, PUT request, delete, so much more. The components of an API that I want you to pay attention to are endpoints, parameters, headers, payloads, and bodies. Payload body is often the same, but those endpoints and parameters you need to really closely pay attention to because you'll often find a version /vx/v1, v2, v3, and you need to know that those can be important things to look at, but we'll get more into that later. First of all, just know that there are different components. These are very important ones. We'll also look at a little bit of a lab later, the basics of an API to get more acquainted. There's the difference between authentication and authorization. When I authenticate, I'm going to log in. When I authorize, I'm going to ask if I'm authorized to do something. Alright, now of course we all know that there's a difference between authentication and authorization, but it's often easy to forget. Authentication is the act of logging in, of authenticating yourself, versus if you want to perform a specific action, then you need to get authorized. So you can compare this as to getting into a club. You know, you need authentication to get in. You need to say, oh, this is me. This is my username, this is my password. Can be just somebody going into a club that they've created and needing to have a secret password. That's your authentication. Versus if they want to perform a certain action and it's above their rank, then they cannot do it, of course. So that's the authorization part. Now, how is this often done? Because that authentication is simple, but once you are authenticated, you need to get authorized, and you don't want to keep entering the same authorization throughout the entire application every time and time again. What you want to do is to replace that with your authorization tokens. That can either be API keys. I think we've all heard of those, but the difference there is that you need to watch which ones are public and which ones are private. OAuth can also be an example, an OAuth token, JWT, the JSON Web Tokens, and basic authentication. These are just some examples, but we'll get more into them later. We are going to learn the details of each of these. Common use cases of APIs, as we've mentioned before, are integrations between software applications, can also be mobile apps fetching data. I mean, come on, these days, if your phone displays the weather, it's going to some kind of API. So everything on your phone often is communicated through APIs, especially anything internet related, of course. Web apps interacting with backend servers as well, and third-party integrations. Some potential risks. I think it is not a secret that when something is this close to the data and when something is this trusted, it is crucial to secure things properly and to put things into their proper security zones. What do I mean by that? For example, if I have a login service versus some service handling a product, just searching of a product, that login service will need to be a lot better protected, of course, in general. Some benefits to using APIs are that it's really easy to scale, but also to build modularly. If you need a new API or if you need a new set of functionalities, you just add an additional API. There's modularity there, but there's also a lot of time saving and integration capabilities, of course, because if I'm writing my application in Java and you're doing .NET and I want those applications to be able to communicate with each other, I can do so through the use of APIs. Remember, it's just your HTTP methods. We'll also briefly touch on API documentation here, not going to go too much into it because we'll get more than extensive research into these topics. Just know that it's important to, well, this documentation, it's important to realize that the developer will write this. So that means that they can exclude anything they want, and if they find something to be a security risk, they will not put it in the documentation, of course. Conclusion, I think it's not a secret how big APIs are getting these days. We need to secure them well, we need to put them in the right security zone. Architecture is going to be more important than ever, but also exploration. And in the next chapters, we'll go deeper into those topics. Now, my friends, it's time to talk about SOAP versus REST APIs, because these two are often compared, but I don't think they are rightfully compared, and we'll get more into that. Let's have a little bit of a brief overview of both. What is SOAP, what is REST, and we're going to talk about why they are developed in a historical context. So SOAP, the Simple Object Access Protocol, this is a access protocol. As you can see, sorry about that, my friends, it's a protocol. So a protocol like this means that it's different than REST. We'll talk about REST in a bit, but you'll see why. What you need to remember about SOAP is that it's always XML-based messaging protocol, and this is protocol independent, meaning that we can use it over SMTP, FTP, HTTP, etc. So that means that we're not bound to those HTTP request methods. This has built-in error handling, and this supports stateful operations by default. As you can see here, this is one of those requests with a post, as we can see, to the /in_stock endpoint with the host example.org, a content application and a content length. You can see the SOAP envelope right here. This is being filled with a SOAP header that contains any authentication details and a SOAP body with, as you can see here, you have your field names and your values in the body, and you end that and then you enter your envelope. You get a envelope back with a body as a response, and again you get those field names with those values. Pretty fucking cool. The components of SOAP contain, as we said before, that envelope, the header as well, containing attributes like your authentication, session information, your body containing the actual request and response information, and the error handling information if a problem occurred. This is what we're going to focus more on though here in this course, which is going to be your REST APIs, your representational state transfer. That is different. This is a state transfer. As you can see, this isn't really a protocol. So that's why I say this is not rightfully so compared with each other very often, REST, SOAP, but we have database APIs as well, such as GraphQL. So there is differences, just so you know. As for here, we can see that with REST, this is stateless interaction. This can be JSON, this can be XML. It's not bound to XML. It's a client-server architecture with cacheable information, a layered system, and a uniform interface. If you want to interface with a REST API, you're going to do it over HTTP methods. An example here, as you can see, with content application JSON right here to the /stock endpoint with a post that's just JSON data. Here we have your field name and your value with a response as well. The components of REST are the resources identified by URIs, HTTP methods, get, post, put, delete, your status code, and as you can remember, in SOAP we also saw a post, but in SOAP it's not dependent on the protocol. In SOAP you can do it over SMTP and FTP as well, for example. The components of REST also contain the status code and the response, of course, and the MIME types. Do we send JSON? Do we send XML? The key differences are the communication methods, SOAP using service operations, REST using CRUD operations, being create, read, update, and delete. The message format, SOAP using XML, REST commonly using JSON, but can use XML, HTML, JSON, anything there. The statefulness of SOAP being stateful or stateless, where REST is always stateless. Remember, SOAP, it's not obligated to be stateful, but it is possible. SOAP has built-in error handling. REST uses the standard HTTP codes, and we can there's performance considerations to be made as well. SOAP parses your XML, which takes a little bit longer, but as you'll see, they have different applications basically. There's also the flexibility and ease of use, where REST is a bit easier to use because it's just your HTTP request methods. It's stateless, so you don't have to worry about any type of state, and you can just interact with it with a JSON. SOAP is often interacted with in legacy systems where the ACID compliance is required and the WS standards are needed, etc. So where we want to have the best available options when it comes to compliance and standardization. So a lot of legacy systems will use that. When we're going to use REST is in modern web and mobile applications. Basically any type of mobile application these days is going to use a REST API. Which is why we're also going to focus a lot more on those, but just know that SOAP is important as well. As for the security implications, we know that both SOAP and REST have their own security implications. Just a little bit of a quick overview, as we've seen before. In SOAP you have different ways of authenticating. Also in REST and SOAP they are passed along in the header, so if communication goes over HTTP, just like anything else, same for REST, you can again eavesdrop on the communication, grab those passwords, But when it comes to very specific things, we will look at that in a bit. There is a big transition going on to modern alternatives. We've already mentioned GraphQL, but gRPC is also a modern alternative. And in the current ecosystem, we can see that these database APIs especially are going to be used much more. As a conclusion, we have seen again SOAP is going to be a lot more compliance based. REST is going to be just implement an easy API with some HTTP communication. Differences are, again, we communicate with SOAP with XML, we communicate with REST through XML, JSON, HTML, etc. There are more differences, but just go back through the slides for that. In the next lessons, we're going to look deeper into these API vulnerabilities, and we're going to have a closer look at GraphQL eventually as well. I want to show you some real-life examples, some APIs that I've made to be as real-life-like as possible, and we'll go through their vulnerabilities as well. Moving on from API keys to bearer tokens. Anybody ever heard of JWT tokens? Well, it's basically the same thing. The difference from a bearer token is an API key is also a token, but a bearer token usually contains encrypted information. Quite a lot about it. You can easily decrypt it, but re-encrypting it's gonna be hard if you don't have the secret key. So if you log on, you get your bearer token from the server, and that is used to authenticate you throughout the application. So let's go for OAuth next, because OAuth, they basically have OAuth 1.0 and 2.0 available. The concept of this is based on tokens as well. We will look at an OAuth playground in a bit, but with OAuth you basically have access tokens and refresh tokens. You get an access token, but it's not valid infinitely. You have to refresh it every now and again, so use your refresh token and your access token to get a new access token and a new refresh token that you need to use next time, and it keeps on building like that, which is why it is a lot of security built in. Basically, that access and refresh token will make sure that you need both of those, and you need to have both of them sequentially, so just one isn't really good enough. There are different grant types, such as the authorization code, client credentials, the password, and the implicit. And the OAuth flows, some examples of that are the web server flow, the user agent flow, and the device flow. But again, we'll look at the playground to make this a bit more clear in a little while. As for JSON Web Tokens, JWT, we've talked about this before, these bearer tokens. What do they really consist of? The header, the payload, and the signature. If you go to jwt.io, you can see a perfect example of what that looks like. These can be used in OAuth and other scenarios. Just so you know, you can get a bearer token and a refresh token, that's your access token, and your refresh token to get a new one. Common vulnerabilities in here include signature attacks, token leakage, weak secret keys. OpenID Connect is another one. It's a relationship to OAuth 2. We'll see in the OAuth playground as well that we can use the OpenID Connect. I'll save the details for then, but this works based on ID tokens and their role in authentication. If we compare them, API keys versus tokens versus JWT keys, we often see that the bearer token is a little bit superior when it comes to security, but when it comes to ease of use, API keys will always win. There are some pros and cons to each and every single one of them, of course, and we'll look at the OAuth usage at bearer tokens as well. Remember, OAuth bases that access token and the refresh token. We have different types of access control, such as the role-based access control, or RBAC. This manages access based on roles. Roles are defined by job functions, and the permissions are tied to roles, not individuals. Very simple. The least privilege here is used. So you're only granted the necessary grants and nothing more than that. This is really easy because you can update it. You can just give a user a new role or add a role or remove a role, and it is scalable as well, as this fits small to large organizations. This also simplifies your compliance checks because in this instance you're easily going to be able to say these roles have these types of permissions and they are assigned to these people. You also have efficiency here, as this reduces administration work. The roles are predefined, so you don't have to give every single person access control, and this minimizes unauthorized access as well, of course. The challenges here are that the definition of these roles can be quite complex versus access based on attributes. Your attribute-based access control gives different attributes. It assigns attributes to a user, to the resource, environmental details. It depends, and this can be very dynamic. This adapts to changing conditions, and the policy here is to define access rules with precise access control. So this is very fine-grained. As for this being context aware, this considers real-time factors and it is flexible as well, as it can handle diverse scenarios, whereas your role-based is a little bit more rigid. This is important for APIs, of course, both of them. It depends. I want to go over some overviews about these as well. So we'll go into the OAuth playground in a bit and we'll look at the different access control ways of implementation. Do I really have to say why rate limiting is important for APIs? I think it's very clear, because otherwise you may be able to consume resources unlimitedly. You may be able to do things like password stuffing. So I don't think I need to go into detail here too much. Some common vulnerabilities and mitigations, we'll look at these in more detail later. What I want to do now is I want to give you guys a little bit of an overview of the things that we've just talked about in a more visual. Now let's talk about API authentication versus authorization. Big difference here. If I'm going to authenticate, I'm going to say, hey, API, this is me, this is Wesley, this is Uncle Red. If I'm going to authorize, I'm going to say, am I allowed to do this, Mr. API, yes or no? So that's the difference between those, and they both a very crucial role in API security. We'll get into what type of authentications there are, so pay close attention because this is super important, of course. First of all, you have basic authentication. Basic authentication is simple. You just take your username, you add a colon, and you add your password, and then you base64 encode that. That's it. So this is not encrypted. If anybody intercepts this, they can easily decode this. Just so you know, this is not super secure. It is not recommended to use it, but it is still used quite a lot. There are a few vulnerabilities in here. Again, this is not recommended for production for the simple reason that this is very easy to decode. API keys, on the other hand, have the same issue. The only thing is you can't easily decode them. So if I have basic authentication and I catch that, I can decode that and I know your username and password. So that means even if you retract that, which you can do with an API key, I can retract my API key and then it's no longer valid. It is just a key that you pass along, usually in a header or something. But again, the risks here are greater because of the exposure. There's a lack of user-specific context because everybody's going to be using that API key. That means that there isn't really a authentication before it, and it's limited security. Okay, amazing hackers, time to look at this through code. We'll start with the API key because this is basically one of the simplest forms, as you can see here. What we're going to do at the first line is we're going to from Flask import Flask itself. We're going to import a request. We're going to import JSONify and abort. So when we look at this, we can see here the app equals Flask and then underscore underscore name underscore underscore. That is just us defining the application. Next up, we have an API key, which you're gonna have to put your API key in yourself, in API underscore key equals, and there you can determine any API key. Right now, this is a hard-coded API key, which is usually not how it's done. This API key is usually stored in a database, and certain people will know certain API keys. So what we can do is here you can see the ampersand app dot before underscore request. Before every request, we're going to require this API key. Here we can see if the request dot headers dot get x dash API dash key is different from the API key, we're gonna say 401 unauthorized access. Then we have a route on here, app.route, which is just your subdirectory, your endpoint, you can look at this as, which is going to display data. This is just regular data, and we're going to run this on port 102. If you're going to run this yourself with Python, you're going to have to install Flask, pip or pip3 install Flask. And if you can see here, this is gonna run on port 102. So that means that you can reach this API endpoint basically at 127.0.0.1 and then your colon 102. We'll look at this in detail as well. But if you're going to request the /API/data endpoint without including the proper header, without including that required API key, your request will fail with a 401. Hope that's clear, my friends. And here we have basic authentication in front of us. As you can see, again, we're using a Flask, but we're also going to use Flask underscore HTTP auth. So if you haven't had that installed, you know what to do. Pip install, pip3 install, depending on your distribution of Python that you're using. But I'm going to assume most of you will be using Python 3. So that will be pip3 space install space Flask or Flask underscore HTTP auth, depending on what you're using. But we'll get to that with the execution part, of course. Here we can see app equals Flask, and then we have again underscore underscore name. This is just the initialization of the application of the API itself, with auth being HTTP basic auth. So we define what authentication means, what it's going to be doing. It's going to be the basic auth in this case, and we have two usernames, user1 and user2, with password1 and password2. How this is going to work is you have a method auth.verifyPassword, which is going to, if the username in users, so if you enter a username and it is within this array of users that you can see right here, then it's going to compare that username's password, and if that is correct, it will return the username. If we go to the route API/API, we can see that we have auth.login required right here. This means we're gonna have to log in. This will execute that verify password method that is indicated by that ampersand auth and then the verify password right here. So then we're going to move on. If that verification is successful, return JSONify, so we get data again. There's an error handler as well for a 401 error. If a 401 error occurs, we're going to make a response with message authentication required. That basic auth says it all. That means that you have your username, password, base64 encoded. You're gonna send it along as a basic header. So you have an authorization header, basic space, whatever you're going to do here, but we'll say that again if we're gonna run. And this one runs on port 101 for you. And then one last thing I wanted to show you, if my staff will stop bothering me, that is you have the JWT token as well. You can see here that we have a secret key defined that will be for encrypting your JWT tokens. So that secret key is used to encode and decode. Even in production, you don't want this to be leaked out, but you want this to be secure as well, of course. So you want this to be a long random string with a, as you can see here, we're going to say your token is required. We're going to wrap this in a decorator, your ampersand wraps. And here we're going to say define that decorated thing. We have a token equals none. You start out with no token, and then the JWT is passed in the authorization header. So the authorization header, we've seen that before. There the token should be in authorization, your colon, and then bearer space your token. This, as you can see, will try to grab that token by splitting that authorization header up on the space and grabbing the first element. The space is bearer space, and the first element, not element 0, is going to be JWT. And then if not the token, so if that token isn't within the request, it says forgery forbidden, your token is missing. Then it's going to try to decode that JWT token with that secret key. And here, if it is not able to do that through a signature error, it's going to throw a 401 token expired. If it says the token is invalid, it'll say invalid token, login again. Then we will return that decorated function, and if you see everything combined, it says in the very bottom apps.route/API/data and then at token required. Remember that token required is at the very top right here. So it says that wrapper needs to be executed first. I'm going to wrap the get data in the token required function, and I'm going to return data if I'm allowed. The abort here basically says if something goes wrong, abort means the data should not be returned. But I don't think this is really safe. I would even put something in, if everything is okay, then do not abort or something like that, because here you run the risk of missing certain edge cases that you did not think of, which might lead to the code still being executed, even though you did not expect it to, because the abort has been skipped. Alright, amazing hackers, let's focus for a moment on the OAuth 2.0 playground. And here, as you can see, they try to give you the flow step by step so you understand fully. The first step here would be to register a new client. This can be pretty quickly. As you can see here, we have our client information. I'm going to open this in a new window so I have it available with a client ID and a client secret. Now, as you can see, there are different OAuth flows below. We have the authorization code, PKCE, implicit device code, and OpenID Connect. We'll look at the authorization code first. In here we have, as you can see, a request with a response type being code, the client ID being the one we just created, and a redirect URI. Basically, when we have logged in, where is it supposed to redirect us towards? Next up, what is the scope of this token that we are requesting, and the state. So let's make this request. As you can see, we are asked for our username and password, Naughty Wild Beast 66. That definitely fits my style. There we go, and we're going to add in the password as well. And now it's going to ask us, as you can see here, this scope would like the ability to access your photos. If we look back at that scope from below or above, we could definitely see that coming back. Now we have a state that is returned here, and we're going to have to verify that that state parameter matches the value stored in the user's session so that we can protect against CSRF attacks. So yes, this is a CSRF token to a large degree, and depending on how you've stored the state parameter, in step 1 previously we have stored the state in a cookie. For this demo, we're going to verify that it matches the state that was originally set. Does that state stored by the client match the state in the redirect? Then we're going to continue, and here we can exchange our code. As you can see here, we have a code that we're going to exchange for an authorization code. We need the client ID and the client secret once again, and we have that redirect URI, and if we go, we get an actual token, as you see. So this is quite a expansive workflow, but it is important to realize how this works. You have your scope, which is important, client secret and client ID, which are important, your code that is being important here, and your state as well. If we go and start over for a moment, we can see here that we have a state that we do pass along when we enter our username and password once again. So let's copy this. What the hell was that? I just need to copy that. Thank you very much. And we can log in. We want to exit. Here we can see that state returning SYGQUL. This does continue, so we can't go over that flow again, but it's the same thing. Then we have the OpenID Connect, which I also wanted to show, which is basically starting very similarly. We have a scope, a state, but this time a nonce is actually added. We have a client ID as per usual and a redirect URI. We're going to authorize again with the data that we have gotten in the past. Inquisitive Lizard 66. I'm more like Inquisitive Rat, am I right? And then we say sign in because we do want to give it access. That state is being verified again. And now we are, as you can see, we have that code as per usual. We send in the client secret because that state matches the client ID and the redirect URI. And if we do that, we get a ID token. So we have our access token in here and an ID token. As you can see, it is merely the response that differs to a large degree. There might be a field here or two that is different, but it's usually going to be the response, what we're going to be receiving. Let's do that with a PKCE though, because this is a little bit different. First of all, we need to generate a code verifier and a code challenge. This is important. The client needs to store that code verifier for later. It's going to be stored in a cookie for this demo. And as you can see, we do this request again with the client ID, the scope, the state, but this time we add the code challenge and the code challenge method. If we log in again then, so we're going to take again all of this data and enter it. When we log in, it's going to ask us which scope this does apply towards. Same thing, yep, all fine. But here we enter a code and a code verifier in step 4. If we then look at this response, we have an access token and, as you can see, a refresh token. It's important to realize that if you request a new access token, your refresh token will also be a new one. We have 2 more flows to go. The implicit one, here we can see that it's going to be largely the same as before. There we go, we give it the grant, but here you can see that you get redirected with information such as an access token and the token type, the expiration date and the scope. If that matches, we're going to extract that access token. We're going to see that this is a bearer token. It expires in a certain period and it has a scope. One more, then we have the device code, which will be the last one. This is, as you can see, is going to request your device code very first. Then it's going to tell the user to enter the code. This is your multi-factor authentication thing. So you can see that we have a device code, a user code, a verification URI, an interval and an expiration. We are going to pull this token endpoint with a grant type. Don't worry too much about that yet. It's a whole lot of mumbo jumbo, but basically this means your grant type. So you have the grant type device code, the parameters OAuth, IETF, URN. It's gonna be 90% the same every single time. And then you have your device code in here, and we see that we have a bad request. Why is that? Because we had something pending already. If we repeat this request, we do get a bearer token, an access token, in this case with a refresh token. So these are authentication flows for OAuth. We also have a few labs on those just to learn how to authenticate, but we're not going to start these up for you. I think it's important that we start to learn how to read Python properly. So we're going to focus a little bit on that, and then I'm going to ask you to start these labs up yourself. It's just Python. This should be super easy for you. So let's dive into that a little bit more, shall we? OAuth, on the other hand, is a little bit more complex. So again, we have from Flask import Flask. We're going to use that, redirect the request and the session. And here we also are going to use the requests underscore OAuth lib. And we're going to use the OAuth do session from it. First of all, again, we initialize our app and then we define a secret key. Since you remember, when you registered, you were getting a client ID and a client secret. We have that as well below. So we have a secret key, a client ID, and a client secret, and specific scopes that we can set up. So in this case, there's only one scope. There's a very easy to guess client ID and client secret. These things would usually be gotten from a database, of course. Then we're going to replace with the authentication service URL that we have. So we're, as you can see, using auth.server.com. That is not the one we want to actually be using. We don't have anything set up, which is why this one will be the only one which doesn't have OAuth properly set up. But we can configure that later as well, of course, because as we know from the OAuth playground, if we go back there, right here, the OAuth playground, we can see that if we use this authorization code thingy, for example, if we go back to our labs, we have that authentication URL because it is authorization-server.com. We could be using that, but we would be relying on an external authorization server. This is not how you would do things in reality, of course. We'll try to adjust our code so it works with the external authorization server so you have an idea, and then you can see the redirect URI being localhost port 5000. That's not correct because this runs on port 100, so that should in theory be adjusted as well if you want to run this properly. We're not going to build our own authentication servers. I will give you an example just to show you what it's like, but that's about it. That token URL as well. We're not going to build a full token server. I'm going to show you a basic example, but know that security isn't fully implemented there. Anyway, for user authorization, step 1, we're going to redirect the user/resource owner to the OAuth provider, i.e. GitHub. In this case, could be using an URL with a few key OAuth parameters, such as the OAuth session, the authorization URL we have already looked at. We want the scope there, the redirect URI, and the client ID. Back to our example for a moment, we see that here as well, client ID, redirect URI, and the scope. The state here is not passed along just yet. In step 2, we're going to actually do the user authorization. Here we have a little bit of extra fields, so we're going to send that client ID again, the state, the redirect URI, and we're going to grab a token with the token URL, the client secret, and the authorization response from the step above it. Then we can see that we are getting a token and we can make our API call retrieving the data. It's not comparable to these steps because this is one step, and then after your login, step 2 and 3 for the OAuth playground are sort of connected here in step 3. 2, and then that last one, basically it's, well, actually all of the steps except for the first one are in step 2. Step 3 you don't really have even in the OAuth playground, but this is just using that session ID that you've gotten, and we're going to grab the response basically from the server. So it's not as easy as it may seem. Sometimes it can be a little bit confusing, but this is a good example of what basic OAuth implementation would look like. We'll have a look at the OAuth server and the OAuth token issue. Well, is it token issue? I guess so. We'll have a look at that code as well for you. To talk about API architectures, let's talk about them because there's so many things that are important with API architectures. You're gonna REST, you're gonna SOAP, you're gonna monolith, you're gonna microservice, you're gonna in-cloud, you're gonna hybrid, you're gonna on-prem. All of these things matter and we need to talk about them. It's important for any type of pen tester hacking that we're going to do. And this is really important for copy, so pay attention. Monolithic versus microservice architectures, the name says it all. Usually, like a company that doesn't have too much experience will start out with building one bigger API, but then realize that that's not as secure and not as performant as they want it to be. That's what an API monolith is, just one API, one server with one API on it that does everything. You can have that in multiple forms where you have subdirectories for different endpoints, for example, but the whole idea is that it doesn't consist of many different microservices, which is basically if you have, for example, one API for logging in, one API for game logic, one API for friendship and chatting. These are microservices. You can distribute them within microservices. They are not inherent microservices, but what that means is that you could make it so that you have one API for your login. You can then secure that a lot more. So if I ask you what a monolith is versus a microservice and you're not able to answer me, well, yeah, you know what happens. API gateways then. Once you are working with multiple APIs or microservices, it's important that you put an API gateway in front of it as a developer. That's just usually what we talk to as hackers. We're usually looking at API gateways. This is when you have one like gate, basically, that's how you need to see it. And then your internal network can be a lot more secure, and you can put different security on the routes to the different services. So from the gateway to service 1, you could have very different security because it's a simple service than from the API gateway to the authentication service, of course. All of these different services could talk to the same databases or to different databases. That's also important within the architecture, of course. There's also, I don't know if you guys notice, but you have fast platforms which basically offer functions as services. AWS has that as lambdas. Now what a lambda is you can set up an API, but at a certain point in the cloud you might have different peaks. You want to catch these peaks in traffic, and lambdas are different like fast functions as services which can be started up. There are security considerations specific to serverless that you need to take into account. We're not going to go too deep into them, but one of the exploits, for example, that I was able to do is when you start up Lambda servers and you don't configure it properly, it can keep starting up Lambda servers while you're still sending requests. And as a performance test engineer, it's not too difficult to send a few thousand requests at the same time, draining the customer's budgets. Never do that in a production environment, or never even execute that attack without really asking permission, duh. What about GraphQL architecture then? Because that is even different still. In GraphQL architecture, you talk to a GraphQL server as a customer, or as a client I should say, and that client will then get a response from the server, but internally that server will resolve your query through a resolver function and fetch your data through different data sources. Can be through external APIs or databases. Then it will return that data in the response. Our resolvers, queries, and mutations that you need to take into account. I'm not going to go too deep into that. Look up GraphQL if you're interested. But there are potential vulnerabilities in here like batch query attacks. And the beauty is, if you know a lot about GraphQL, not every hacker knows a lot about GraphQL, so that gives you an inherent advantage. I think we skipped one because I'm going straight to number 7. That's not correct. Ooh. Let's see, previous, no, I just need to go to number 6, API compositions. So the idea is that we want to combine sometimes multiple API calls into a single response. Why is that? For example, if you log in, you need to get a one-time token or multi-factor authentication. That could be a server, and the login could be a server. Then you have what's known as a backend for front-end design. In it, you're going to send a request and a response comes back as normal, but aggregate data will be gathered from different sources or services, different APIs basically. So the whole difference here is that in microservice API architecture, you're going to directly talk to microservices. In API gateway, you're going to talk to the API gateway, which will translate to one microservice, and an API composition, you're going to aggregate different services together. I told you guys, this is not a beginner certificate. You need to be able to recognize these things. Now I skipped one more, stateful versus stateless APIs. What we need to discover here or talk about is that in a stateful API, your session storage is being taken into account. So when you do something and another call is being made, for example, the /users/me endpoint, that knows who you are, so that takes session storage into account because you don't give a user identifier. If you have a /users/me, it'll look at who me is and it'll give you information for that user. That's a stateful API. Versus if you're just getting a product and you have to give it an identifier and you have to give an authentication token to it and everything, that's not a stateful API anymore. There's no session state being maintained there. In API versioning, and that's also between calls, by the way. So you do one call and another. These calls know about their session status. In API versioning, this is an important one because you'll often encounter different versions of APIs. So you'll have like API version 1 and then they're working on version 2. Well, guess what? Sometimes you have to deploy into production and code for version 2 gets put into production. Or you upgrade to version 2 and version 1 stays in, or something like that. Getting to know that is important. Knowing these informations you can get through Wayback Machine, for example, or Internet Archivers if they have public documentation. That saves that documentation to a degree. If they don't have that public documentation, venture a guess and just replace version 1 with version 2 everywhere. See if they have anything in production that is not supposed to be. Common strategies for versioning include they will put it in the URI /v2. They'll put it in a header sometimes, or they'll put it in a parameter. $v equals and then some kind of weird string. That's also how versioning for APIs is sometimes done. The security implication of maintaining old API versions, we don't have to talk about that, I think, right? Give us those old API versions. Yes, please. Thank you very much, sir. Websockets and API architectures are really weird shits, really weird, because up until recently Burp Suite wasn't even able to do anything about WebSockets. You had to like really program your man-in-the-middle proxy in Python to, for WebSockets, be able to like communicate, because it's not an HTTP request, of course. When you make a WebSocket request and a response comes back, you know as well as I do that it's pretty much immediate. Like chats, for example. Chats are premium examples of this. WebSockets have two-way communication open at all times. You make it, well, not at all times, but as long as you have a connection with it and want to communicate with it, they have two-way communication open. WebSockets still connect to backend services like databases or external APIs, just so you know. and they traditional from different REST calls or HTTP calls. Of course, use cases I've already talked about chat, but also casinos are our premium example, or online games. Rate limiting or throttling, well, that's important because when you talk about different architectures, rate limiting and throttling might be differently implemented on different components of your system. That makes sense, right? Because you need different rate limiting on the authentication endpoint than on the chat endpoint, for example. This is important when you talk about API strategies, and it has big implications throughout applications. There's a big role in maintaining API's health and security in rate limiting and throttling, and the difference of course is that in rate limiting you're going to see once a certain rate has exceeded, you will limit users from your application. In throttling, you will throttle them back until they have such a slow response time that it's no longer feasible for them to do any type of automated attacks. It's important, really important, that you in this case realize that rate limiting can differ based on what you're talking to. A rate limit in the cloud can be different than a rate limit on-prem, can be different than a rate limit from whatever the server can handle, or the different server architectures. I think we need to talk about caching as well, because caching is something that often occurs. There are benefits, of course, as you can see on the picture. When a web application takes on a request, it can serve some kind of cached data, and that cache is basically like if your application is constantly asking for like pictures or stuff like that, and it's consistently downloading pictures and pictures and pictures onto users' devices, your servers might get overloaded if there's a lot of traffic. So caches are put in front of that. It's different from content delivery networks. Very clear about that. It's also sort of a cache, but not really. CDNs use caching though. The thing is, with a cache, attackers can send malicious data into a cache, and if other people see that cached data, they have an exploit that may be executed. Sorry about that squeaking. Containerization is an important factor, especially these days where we're talking about containerization like Docker or Postman or whatever. If you work with these before, basically Docker is a container. What is a container? If you want to run an application and you want to run it on a Unix system, you are going to have to deal with every little crap that Unix has installed alongside what you need. So a container is just a very stripped down version of a virtual machine that runs your applications and code snippets and stuff like that. This is a very trimmed down version of what containerization is, and on top of containerization you also have orchestration, because you might have, like you saw before, multi-API architectures, which are really big when you Dockerize them or containerize them. And if you then do something through what's the name again, OpenShift platform or something, OCP, if you do something through there, you can actually very easily orchestrate them. There are of course a lot of potential benefits, but the security risks are also greater with this, because you have increased architecture, which is increased complexity, which is always increased security risks. There is importance of secure container orchestration, that's Kubernetes as well, that's also OCP that I was talking about, but these are orchestrations for your containers through things like Helm files. Then you have logging and monitoring in API architecture. This is vital for security and diagnostics, of course. And of course, as an ethical hacker, really important to see if we can bypass any type of logging or even inject certain things in logs, because logs are read by other applications as well. What to log and what not to log is really a very touchy subject, so I'm not going to go into that. Everybody has their own opinions on it, but like I said before, sensitive data can end up in logs, or inadequate logging is just as much as a risk of too much logging in that regard. That's it for architecture. It's really important that you go through all of this very closely. Watch the words that I've said, because these things matter. If you don't understand something, Google it, because in copy, if I ask you questions like explain to me different architectures, explain to me API gateways, GraphQL, what the hell is that, explain to me WebSockets, and I get some kind of ChatGPT piece of shit answer, then you're going to fail easily, of course. Now that's it for this chapter. I'm gonna see you guys in the next one. This was all for copy that I was talking about, by the way, which is one of our API certificates. So if you're interested in copy, I am also going to put the page below. It's going to be announced soon. This is going to be part of the content for that certification. I think it's important that everybody knows what you can encounter in the wild and that you're trained to identify these kinds of things. Let's talk about API documentation, my friends, because of course, like, we need to know how to interact with APIs, but know that documentation is created by developers, so it can also be hidden and obfuscated by developers, meaning that if you come across any piece of API documentation, take that with a grain of salt. It might not work, it might not work as expected, it might be outdated, it might be incomplete. You just need to be present and ready for these types of things. What makes a good API documentation? We'll look at that. What is really important is endpoints and methods, of course, parameters, the required ones versus the optional ones, request and respond examples, and status code and error codes as well. We're also going to look at rate limitations and other considerations once again. If we talk about anything related to API documentation, a lot of you might know Swagger. Well, that's Open API specifications. Basically, Open API specifications use Swagger for interactive API documentation. There are security benefits of standardized documentation, since you only have to define your documentation and it'll auto-generate it for you. You can then import that in Postman in certain collections as well, but Postman collections are just as much API documentation as anything else. So if you go on GitHub and you find a Postman collection, you should know how to work that tool by now. That's just as much API documentation as anything else. Creating, sharing, using collections for documentation purposes is important, and if you find it, use it, for fuck's sake. Potential security considerations are that you might have hard-coded credentials in these collections. Happens more than you think. API Blueprint is also a documentation or documentation style. It's a markdown based syntax. It compares with OpenAPI Swagger, and I have a link if you want to go check that out. Documenting authentication and authorization is important. Clear instructions about that matters, because sometimes you need API keys, sometimes you need authentication tokens that you first need to log on for, sometimes you need blah 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 blah. It's important that that's documented very well, and that's not always the case. Developers might neglect to document that. Versioning, and so if you find an endpoint where it doesn't say that you need authentication, you might still, that's what I'm trying to say. Versioning and documentation, of course, we have the same as with your endpoints. You can have different versions of documentation as well. This is usually something that's less important than just using or finding an API with older versioning or newer versioning for that matter, but it's important to know. The benefits of that try it out interactive documentation thingy are that it's easier for us, because we can try things out through a web interface, but don't get too comfortable. Learn how to interact with these same, because you can just make this into curl commands, you know. Swagger gives you curl commands as well. You can make those into Python scripts if you want to, but make scripts and don't just keep it as is. Interactive documentation can aid you in understanding and testing, but don't get too comfortable with it. You need to also try and guess some endpoints, you need to try and guess some parameters. Ain't no way you can do that if you just rely on documentation, of course, alone. Common pitfalls in API documentation are that there's outdated information, that it's not really clear on how to log in. Sometimes you might have to look on GitHub for how other people did it, and there's sometimes missing information on edge cases or even error handling. What if you enter this value? What if you enter this value? Etc. Business logic is not part of that. The role of documentation and security, of course, if you have good documentation, it's great for us. Duh, of course, what else? But of course it's not that good for developers. Of course the documentation itself is good, but not if we get that in our hands. So what can they do about it is secure that documentation very well, ensure that it's only reachable from internal sources and stuff like that. But we all know how developers work, right guys? They don't do that. Hey, what's up you amazing hackers? Welcome back. Hope you're all doing well today. Let's talk a little bit about Postman and API testing, because of course Burp Suite's not the only tool that we can use in our arsenal. Now, Postman is a really cool tool specifically made for API testing, and we're going to go through it live. So if I make a mistake, bear with me. I think mistakes are learning experiences, which is why I don't cut them out as often. Now, first of all, we're going to need to make a workspace. Now, for me at least, I make one specific workspace, and then I make collections per target. Collection is basically a term for Postman, and collection is a collection of API calls that you can execute. So let's call this one test for the workspace, because after this I'm going to throw this workspace away. Of course, there's no team in here yet. You can invite team members, up to 2 others in the free version. So it might be an idea to do that. And of course you can upload a file as well, which we might do. I like uploading my own graphics to this kind of stuff. So let's put this one in. This one was made by Clucky. Oh, right. Sorry, this is my mistake, first mistake. Try to upload a bulk invite people and upload the image file. Way to go, Mr. Rat. There we go. So we have our workspace now. This is our workspace completely. It might seem barren and weird and strange, but we're going to go through all of this. And we're going to go through all of this with the use of this JSON placeholder API. It's basically just a test API that we can use to execute our calls on and to see what we can do. Now, first of all, you guys know what a get call is, you guys know what a post call is, so I'm not gonna explain that kind of stuff anymore. Let's dive straight in and create a request. They have a request on the home page. As you can see, they're fetching specific to-dos, so that's something that we can also do. Now you can create your workspace per target if you want. That way you can create a collection per feature. I like to keep my collections per target. So first things first, I'm going to create my collection, and of course this one is going to be a collection for the JSON placeholder type. So let's just rename it collection. There we go. And then of course I can do some git stuff in here if I want to as well. I can also run my collection, as you guys can see in here, and we'll talk about the runner later. And then you can set up your authorization for every single request in your collection. That way you won't have to set it for every request separately, but there are other ways as well. We have a pre-request script, which is really useful. There are several things we can do with this. If we want to manipulate our data in any way, for example, base64 encoded before we send it over, that's possible. If we want to grab data from another page, insert it in here, and change some values in it, that's also possible. So that's what the pre-request script is for. And the test is, as it says, for testing, but you can also do other stuff with this test tab. You can, for example, extract variables from a specific call, but that's something we're going to talk a little bit more about later. Then we have variables specific as well to this one collection. Now, you have variables in Postman that run on specific levels. So you have your global variables. Your global variables will run on everything, on every workspace, on every collection, on every single API call that's being made. Then you have your environment variables. Those will depend on the environment that we set here. At the moment we don't have one yet, but we'll get deeper into that later on as well, of course. And then you have your collection variables. You can also have a variable specific to an API call if you really have to. So there are many different scopes of these variables, and I advise you to look into it, because of course we can go over them all, but I think it's more useful if you look into it before the next episode, and then maybe you can compare the results that you got from me. So basically right now we don't want any of this stuff. I just want to write myself one API call, that's it. So what they're doing is a GET request here, very simple. That's something that we can do as well. So now we have our collection in here, JSON placeholder collection. Now we need a new request, of course. So we have several different ways of doing that. I just used the plus here. This is the collection, this is the collections tab, of course. There we go, another environment. There's also the APIs tab, the environments tab, the monitors tab, and the history tab. Now I don't know why I don't see my collection in here, but let's try this real quick. No, not seeing my collection. That's not very fun. So why is it not showing? Is there a filter? No, there's no filter set. It's not that important, but I do need my collection for my requests, of course. I'm going to have to look into this later on. Now, I'm just going to go back through here, and then I can create my API request in here as well. There we go. And this API request, again, I'm going to need a GET request to this specific URL. Oh, I didn't copy it properly there. There we go. There we go. So that's a call to a URL with a specific URI in it, and that's going to return a value if I make it. It's as easy as that. There's nothing that you can do in here like that's easier, just a very basic GET request. Then we can play with the parameters a little bit, if there are parameters, of course. For this one, you can see that the only parameter in here will be the to-dos, and then we can just change the value of the to-dos if we want to. That's a possibility. See if we can get a to-do that we're not supposed to be able to see, for example. So that's one environment that I'm talking to. This is the environment specifically. Now, let's say that this environment here can change. Sometimes it's this, sometimes it's tst.json placeholder.typecode, and that might be the test environment. So let's make this into a variable. Now, I don't have a variable for this yet. The cool thing about Postman is if you just double click it and select a value, for example, I want this value, the whole value in here. Quickly select that, there we go. This whole value should basically be a variable. Then I can select it, I can say set as new variable, and this one will be the URL. Set the scope, and then I can set my scope to global environment or collection. Again, there's no environment set, so it's not possible to set it as an environment variable. In this case, it's global, this variable. Now, why would you want to do this? Let's create another request, shall we? Because there's more, of course. There's a request to the /posts that we can make. So let's insert this request as well. Let's call this request something different now. Let's see how we can rename it. There we go. No, that's not the one. Let's just save our request. So we have our collections here. I don't know why I'm not seeing them in my list in the left options menu, but I'll look into that and I'll get back to you guys in the next video. So now I have saved my specific request. I can give it a name as well. In this case, it's going to be the get for the to-dos / value, of course. And this will help me understand my request better, see what it's all about. Now, since I am not seeing it in here, I'm going to be very careful that I don't close it in here, then I might lose it. And now we have our second request. So the same thing is going to happen. We're just going to grab all of the posts in here, all of them, not the specific one. But now let's say we have two calls. What if we want to change this URL? It's going to take a lot of patience to change the URL and 100 requests. That's exactly why I always make my URL variable. Really interesting functionality for Postman, that you can make it variable that easily. You can just double click it, set as variable, and you're done. Of course, the scope matters, so let's start by setting up an environment. That's something we haven't done yet. I can click the eye here, and then I can see which variables are active at the moment, also the initial values and the current values, because those can change over time. So it's important that we know that. And now we have an environment open in front of us. This is going to be, let's call this the test environment. And we can put the URL variable in here, but for me, let's see, so I can't put the URL variable in here right now, sorry about that. And then it would be gone from the global variables list. It's pretty useful to do that, and I would definitely recommend it. Now, very basic request, again, JSON post, nothing specific about this. We can name the request something differently. Let's call this one get posts, get / posts. There we go, there's no identifier behind it. And that's our get request. Now let's talk a little bit about post and put requests as well, because that's something that we haven't done before. We can make a post request to the post call. So let's say I have a put request. As you guys can see here, you can make a put to a specific post. So let's do that, shall we, real quick. Let's grab post number 2. Let's see what its current value is. And then let's make a put call to that specific endpoint. Now, some of you might have already seen this. It's not going to work like this because I don't have any variables. All I can see now is my ID is 2. So let's make it a get request again to see what we need, what we have here. It turns out that body is going to be one of these specific parameters that we can adjust. So body is something that's going to be in our body because it's going to be a put request again. And then this body, let's just change it to a form data, or let's make it raw. That's easier. There we go. And I can just paste my values in here, and then I can possibly change some of these values. So let's see what this gives me. It says ID number 2 in here. I don't know if it worked right now. So what I can do again is make a get request. I'm going to make it a new get request because this one is our post request now. And then I'm going to make a get request to that specific post that we've talked about before. Now, it gives us back values, but they didn't work. It can be that the API here is at fault, I say, but it can just be like, as you see, I didn't read their guide properly, but the put methods, that's something that we can look into right now. So let's see, the put method, it's patching a resource. So that's going to be a patch. Then we have a put, that's it, this one. So as you can see here, they also have the same things as we do. They have a method, a put method, a specific body. That's something that we also have right here in our request. So let's make it a put request. Let's grab that real quick again. There we go. So we also have a body. Only thing is ours is raw data, as you can see here, which is not the correct format because they expect some JSON data. So we need to, of course, form data is good, that's okay. We can put our variables in here. We can also just make sure that we give it that specific input value that it needs, that we give it that JSON file by setting the content type, as you can see here, to application/JSON. That's something that we can do. It's a specific header in this case. So as you can see, there are quite a lot of hidden headers already. And we can add another key in here. Keys is going to be the variable names. And this is going to be content type as a header. And we're working on the put requests here, right? Yep, that's put requests. Let us quickly rename that as well so that we don't keep getting confused by it. There we go. And then we add that header. There we go. And let's add the value as well. Et voilà. There we go, we changed that. Let's try it again with raw data. Let's see what it says now. As you can see, it's colored in nicely. That's because it now knows what we're talking with. And as you can see, the body has been updated in this case. So we've just created a put request in here. And in this put request, we can change specific values. Now, we know how to make a get request, we know how to make a put request, and this time I forgot to replace this with a variable. So let's do that real quick. Now you can also see what it looks like. If I know what the variable name is, I can just click it and bam, I have my variable. So super useful tool. That's a get request, a post request, a put request. Post request is going to be very similar. Then you have your delete request, of course. Delete request is just a URL. And then you also have a host of other options that you can get by calling the options method. If you do it like this, options on this specific URL, it should return this what you can do, but I think I'm doing something wrong here. I just need the options. No, it's not returning it. Doesn't matter. Anyway, a options call would return a what's possible, which calls can be made on that endpoint. So let's look a little bit about these other things, because of course you can also patch a resource, same thing. We just need to make sure that we have the good header there. Patch is going to be probably just only one specific field. And then deleting a resource is something that we can also do. It won't be deleted for real, as you can see here. And as you can see here, if we patch or put, the resource will not really be updated on the server, because of course that would mess up the server for quite a lot of people. Now, something else I wanted to show you as well is, let's say we want a filter on that. Let's say we have a parameter in the URL here. This endpoint, let's make a new endpoint. Let's copy this one over. Is that possible? No, let's just create a new API call then. So we're going to create a new API call. This is going to be a GET request to this specific URL. And again, I'm going to make my URL itself variable. There we go, user ID equals 1. And now if I send this over, you can see that I grab all of the posts from a specific user. So now I have some parameters in here. These parameters are things that I can play with. I can try user ID equals single quote, and I should be maybe expecting a database error. I can also try double quote, of course. There's many different things that you can do. You always have to judge each parameter in its own right. So that's how you create all of these specific calls if you don't have things that are set up for you. Sometimes targets will expose a complete WSDL file is what they're called, and they basically contain a description of their entire API. You can easily import that into Postman, and that way you can very easily get started. You don't have to spend a lot of time setting things up properly. You can basically just immediately get started. Now, besides the collections, of course, we can also have a monitor. So if we have a collection that we want to run every now and again, I don't know why you would do it, but you might have a reason for it. No environment, let's run it on test, and then we can create it. So what this monitor will do is it will automatically run my tests every time that I basically set it up to run those. Right now it's running them. You can see it as it goes, and you have a summary of your run. Here we have no tests found. That's normal. We're not testing anything. That's something that we're going to look into later. But for now, all you want to do is change some of these parameters around. I see user ID equals 1 here. I make user ID equals 2 here. Now, one interesting thing you can also do is if you get a response, what you should always do is, let's send this over to the server. I'm not getting any response anymore because I have the completely wrong method selected. There we go, a put request. So we have some values in here. Sometimes there might be values in the response that are not on the request, but they might seem impactful, like account type and all of that stuff. Then it's your job to copy those over and see if you can't play with them a little bit. Because before you know it, you'll be admin and bam, that's a huge vulnerability, of course. Now, I would recommend that you guys take a lot of time getting your notes right, getting your titles properly set up, getting your collection set up the way you want that. I always say that people should spend 70% preparing and 30% executing, but that's my little autistic brain, I think. But this is not all for Postman, of course. This is just the very basics. There is much more that we can do, and my friends, we will do that later on as well. I still can't see my collections. That is frustrating, but it's okay. I'll figure it out and we'll go over it next time. Thank you very much for watching, and I hope I will see you in the next episode. Bye, amazing hacker. Welcome back, amazing hackers, to part 2 of this amazing series. Right now, I'm going to teach you guys how to import, because I'm very sure that you've all come across something like this before. Now, in here, this is just an example, Swagger. Swagger is amazing. It completely documents your API and you don't have to do much for it yourself. Of course, this is fun to play with. This is very fun to play with, but it can be cumbersome. Like, look at how cumbersome all of this is. I have to click open, I have to click on it, I have to click on it. That's way too much for me. And then, of course, you can also authorize. That's also possible. But what I really want to do, and that's the easiest part, I think, wrong tab there. So I want to import it. Like, I can either import a file, of course, a complete folder. I can import a link, which is what we're going to do, or raw text. That's also possible. Or we can implement a complete Git code repository. Now we want to link it, and then we can immediately see it's found something. It's going to enable that Swagger API. It's going to generate a collection from the important APIs. This is important. Either you generate it or you put it in an existing one. But for me, generation is good. Link this collection as documentation. That's good for me. Now you also have some advanced settings that you can play with. Make sure that you look into all of them, because there's some really advanced stuff in there. Then we click on the import button, we wait a little bit, and then we get one API and one collection were important. They'll be in the sidebar in a few seconds. Yeah, right, if it doesn't glitch out, right, guys? And the next step is publish important APIs to private API network. So that's something that still needs to be done. But now let's first have a look at what's new here. Because as you can see, they've been so kind to create a new collection for us. That's really useful. Does save us a lot of time. That means that we don't have to do that anymore. Then there's, of course, their pet store, the pet specifically. You can make a post to a pet. You can make a get to a pet. But this is all the theory that we saw in the previous video. And I hope you guys see how cool this can be whenever you come across API documentation. It doesn't even have to be like me right now. What you can very easily do is you can just import it. It can be anything, open API, as long as it's, of course, a data type that is supported. WADL, Open API, GraphQL, curl, blah, blah, blah. Can be a lot of things now, of course. There's also possibility to add a link in there, which is what we did. But that's how you import, basically, how you import these WSDL files or WADL files. If you ever come across them in the wild, this might be an option for you. You just import it and then you can play with it a little bit better. You don't have to use that cumbersome web version anymore. Thank you so much for listening, everybody. It was a pleasure talking about this. And of course, Burp Suite, sorry, I keep saying Burp Suite. Of course, I mean Postman has a lot more secrets than just this one. Thank you very much, and I will see you in the next one. Bye, amazing hackers. So now we have something already that we can build upon. Let's do that, shall we? We have a couple of GET requests, and we want to test them because, of course, we don't want this GET request to just return any data. We don't want it to return random data. We want it to return sane data. That's very important. So what we're going to do is we're going to, on our GET method, and this one is one that I've already written on beforehand, but I didn't have to, and I'll tell you guys why in a second. So basically, we start our test by indicating PM is the Postman extension that we have. So this is basically JavaScript that I'm writing here in this test field, and you can write any JavaScript that you want, anything in here, as long as it's sane and it's a valid JavaScript, you can run it from here. Now on to what we have in here, because I have several things. I have pm.response, so I'm watching Postman's response for this particular request, and I wanted to have JSON, this particular thing in here. And I can also say, for example, I don't want it to have this in the JSON body. Now this test should fail. Basically it should fail. So let's remove that real quick, because I want to show you guys something. We also have code snippets available, and these are really, really useful. Now you can of course learn more about tests by clicking here, but these code snippets, let's say we want to get a environment variable or a global variable. We can very easily do that by just clicking here, if we are setting our cursor on the correct point, of course. And we can say get a global variable, and then he says pm postmaster.globals, which is the global variables, of course, and you're going to grab one of those keys from there. Really, really useful, because I can, for example, have this status code 200 test, but let's say I want to log some things before I start my test, maybe a variable. I want to log that variable to see what its value is before I even start running. Now, what I can do for that is a pre-request script as well. Console.log is normal JavaScript, and the PM, again, postmaster.globals.get URL in getting a global variable called URL. And I did this by writing console.log and clicking here for getting a global variable. Now you can also set them, of course. And in here, in the pre-request script, there's also a code snippet for sending a request. If you go into the scripts, there's many, many more, of course. Status code is 200, this one is often used. And that's what I meant by I didn't even have to do this. I could just go like this, status code is 200, and bam, I don't even need that test anymore. There we go. And then I can write different tests if I want to. Now, I can write different test conditions in here, or I could write a separate test. Sometimes a test checks for several things. So you might want to check for a status code 200 and the content of the body, but you can also separate them, and you can also say the JSON body must have something. Let's say JSON body contains, and then this particular string, let's make it title. This should be the JSON body that I'm looking at right here. So let's see, it should contain title. I'm going to remove this because that is already tested previously. And then I'm going to move on, and I want to say response body contains string. I'm going to keep it pretty simple here. Remove this. I don't need to copy paste it every time. Apparently the code snippet contains itself, so that's perfect for me. Now, basically, I'm going to see body matches, which means PM postmaster.expect. Postmaster's expect module is running here, and it's expecting this particular text here, so the response, to include whatever we put in here. So let's make that title. There we go, title. And then we have two test cases that we can look at. And now what's going to happen is you're going to see, first of all, two test results. Status code is 200 is a pass, and body matches string is a pass. Now let's change this to status code 201 just to see what happens when you fail. As you can see, you get a fail message, and you get a message what's happening. Assertion error, expected response to have status code 201 but got 200. So let's change this back real quick so that it actually runs, but the title did run. Now, as you guys can see, I have in my pre-request still this console.log. And you might be thinking, okay, it might be JavaScript. JavaScript is a console, we all know that. But where the heck is my console? Well, guys, I was a little bit surprised as well, but it is the very bottom here. You can see your console. Now, I want to go into a couple of things for my console here. First of all, this is what I've been printing out. This is just the value of my URL. Then next on, I can also open a specific request and look at everything from that request. I can do it on network level, but that's not interesting for me. I usually just go to request headers, request body, response body, all of that stuff. And as you can see here, that's easily possible. You can see exactly what response headers you had, what request headers you had. And you can scroll down for the body as well. There we go. So that's the body. This is what was in the body. Now, why might this be useful? I hear you thinking. This is super useful if you're working with variables and you have no idea if your variable was correct, if what you're doing is right. Then you can look into here, and if the body doesn't contain the variable like you expect it to, then you probably did something wrong and you might have to rethink your strategy there a little bit. So that was it for the console. You can do a lot of stuff in here. You can do a lot of debugging in here. Right now I'm getting a global variable, but of course you can do any debugging in here that you want. You can print your normal variables as well. You can print stuff from the response, and you can print stuff from the request. That's always useful. So there are many things we can do here. Same for testing. If you do this, I advise you to write a test every now and again, just to have a little bit of a practice. And I know it's not going to be super useful in bug bounties, but what this is very useful for is if we have our collection here, and I need to save this of course, I can still run my collection. So what I'm going to do is I'm going to go to collections, going to run this one specifically, but I don't need these guys. I only want the put request. Let's take it at that. So we're going to run, there we go, one request made, and I took the wrong one. So let's run again with the proper one. Let's take them all, it's better that way. So let's make a new run, and let's just take them all. So one of them is going to have tests, and you'll see what that looks like in a second. As you can see, this is the run summary, and in here you can see that your body matches string passes and your status code equals 200 passes. That's some good news. In the runner we can all check that out and we can see what we can do there. Now, as for the runner itself, you can tell him to do a lot more iterations than just one. You can tell it to do whatever iterations you want. Of course, there's a limit there. I haven't found it yet, and I wouldn't advise you to find it either. And then, of course, you have a delay which can be set. That's very useful because sometimes some strange caching mechanism might be in place or some weird stuff. So sometimes you really need that delay, and also to keep your requests to a server to a sane level, not too high. I mean by that, of course. Now, when you run, you can run with a data file. I haven't shown you this, and I won't show you this right now. I will make the next video about data sources. Right now we are running with basically very static data. So we can select data files and grab our data from those files while we run. But that's something that I can spend some more time on than just 5 minutes. So you can save your responses, very useful if you're debugging, if you want to know what's coming out of it. Keep variable values, also very important to know just what's going on. Run collection without using stored cookies. This one is also very interesting because some web servers will behave differently if you've already been to that web server. Even just being there can make the web server behave differently because it can put a cookie in your browser, and that particular cookie might tell the website, hey, this guy has been here before. And well, I'll let your imagination run wild on what can happen then. A little bit of rent there, so you can also save your cookies after the run. That might be important because you might want to know in a log setting, so loggings might be enabled. And you might want to know what that cookie did, for example. You can always trace back cookies then to particular users. So always useful for me, I keep it on, but it's up to you guys. So basically that's it for this episode. Thank you all very much for watching. I really enjoyed doing these stuff like with Postman and exploring some other tools. If you guys enjoyed this series, please leave a like and a comment, and I would love to hear from you. I really would. Just tell me what you think, even if it's a terrible thing. Just let me know, and I'll make sure to try and fix it for you. But please just be constructive, of course. Thank you everybody so much for watching. This has been a blast so far, and I will see you guys in the next one. Bye, amazing hackers. Welcome back, amazing hackers. Over the past couple of episodes, we've looked at a couple of things. We've looked at how to work with variables, how to make a GET request, a PUT request, and all these different things. But now let's make things interesting, because as you can see here, we see the option to select a data file. Now this data file is either a CSV or JSON file. So keep that in mind. You can make any file. The way I do it is I just create a new text file. I save it as a CSV file, and there we go. Done. Now you want to replace the values within certain requests. Of course, that's normal. Let's say we have this PUT request here. We want to replace the title with the attack vector that we want, and also the body with the attack vector that we want. Now, if we are running this specifically, so we're going to create two variables here as well, or at least one variable. I'm going to put it on my environment, and that has the same name for me. And then what I'm going to do as an initial value for this attack vector is I'm going to say file not found. That way I know whenever I see file not found that my attack vector is not being loaded properly. Now if I do this request like this particular PUT request in here, you can see that I'll see title and body file not found. Now this might not seem that powerful, might not seem that interesting until you realize that if I am actually in a runner and I select my data file to be the data file that I'm creating right here, all you have to do is to make your first line to be the heading of the CSV file. You need to have every column named as to what it will be. So this will be my attack vector in this instance. Okay, that sounds interesting enough. My attack vector will get replaced in my PUT request from the moment I choose select data file here, and then I can also see my iterations go up as I see the number of attack vectors go up. Now, as you can see, I have a lot in here. ls, some basic command attack vector. I have a SQL injection attack vector. I have some more of that, and I have a cross-site scripting attack vector as well. So these are all very mixed attack vectors, and you might expect a different response from all of those attack vectors. That's all very possible. We can also change this to include that our response has to be different. Now, this is a comma separated value file. That's what they call CSV. So I'm just going to separate my values with my commas in here. And then I want to know what the result is as well. And then I can put in here whatever I expect from the result to be the case. Now in this case, I'm going to expect my response to have a particular thing in the body. Let's say that I want it to have a slash in here, because we'll probably expect, if we are doing a ls, we're going to retrieve a list of files. So, or at least a list of folders as well. So that's what we'll put in here. And then of course we'll still have to replace this. Now for the SQL injection, I am looking for anything that contains the word SQL in it. Same for this one, SQL. The response should contain the word SQL. And for my attack vector for cross-site scripting, I just want this to be the same thing. So my body has to contain all of these in the result. Now in Postman, I still need to adapt my response. So this is going to be my test for this one. It's going to be a test in this case, and I want to test something. I want to test that the body contains, so response body contains string, and there I can put the string in that I want, which in this case will be there we go, if I can select it properly, of course, result. Now I still have to define this variable, and of course you might be seeing that this is not taking, because we are in JavaScript, guys. That's what I keep forgetting. So what I'm going to do is I'm going to set up a global variable as well, and in here I'm going to set the name result with, again, the base value of file not found. Alright, there we go. So let's save those global variables. Shall we go back to our put request? That's in here. And then I need to grab that specific global variable. Of course, I can't do that in the regular way. Going to have to do that programmatically. So we'll get a global variable, set a global variable. It's the same thing as get a global variable, just a little bit different. It will be .get, and of course I will only need the variable key for this one. There we go, and I don't need my trailing semicolon either. Now I'm going to put these things to include. There we go. Now whenever I'm going to run my request, as you'll see probably, it's going to say a couple of things. Of course, I need to change before I forget to pm.toInclude. Am I doing something wrong here? I'm just going to do this again, just to be sure. Just remove this, because I think I've removed a little bit too much code there. So we're going to do response body contains pm.expect yet to include, and then in here, of course, I need to do pm.variables.get, and then the key results. There we go. So whenever I run this script right now, again, it's going to check for file not found exception. That's not going to work. That's of course not what's going to be in that specific response. Oh well, in this case it is, of course. I keep forgetting that, but of course, as you can see in here, my base values for these for title and body were also file not found. So file not found, let's make it file not found exception. That is very smart of me. Exception for this one, results. And then I can make for my global variables, I can make, or at least for the variables that I have into my testing environment, this will be file not found exception for attack vector. At least they'll be different from each other in this case. There we go. So if I save all of this right now, what should be happening is I can start running with my specific data file, and for every single entry in my data file, I'm going to take my attack vector, I'm going to replace it into the body of my request, and then I'm going to test if the response contains my result. So as you can see, this is some very powerful stuff right here. I can automate all of these different attack vectors, and I can automate checking the responses for me. So there's a lot of things that can be done here. Use your imagination. I hope you guys enjoyed, and I will see you in the next video. Bye bye, amazing hackers. Let's have a look at Postman, a really good tool for testing APIs if you ever want to test it. So what we have in here when you start it up is you're gonna see collections. Collections are basically, like the name says, collections of specific API calls that you're going to be able to make. For example, I have this specific one right here where I have, as you can see, URL port. What would that mean, you might be wondering? If I send that, as you can see, I get something. There's something here, so I can go like this. There we go. Send it over. no ID provided, so I'll provide an ID for you, my friend. This is why you never have verbose messages like this. And there's nothing here. Let's look at number 0. Maybe there's something there. Yes, there is. So as you can see, I'm making API requests here, a GET request, but I can also make POST requests and change the body. Right now I don't need that body, so it might as well be empty. As you can see, up there we go. But if I need to put my ID in the body, I can also do that. I definitely have that possibility. Now we also have pre-request scripts in here. Whenever I click send, it's first gonna do this. What is that useful for? For example, setting a specific variable like a JWT token or whatever. Here you can do authentication. Then if you have a login call, in the login call, in the response, you're often gonna find things like that token. You need to extract that. That's what we have these tests for. Test is basically a post request script. That's how you can see it. And you can use this to test your response and see if it contains the right things. But you can also use this to extract information, for example. I also have some settings. I usually don't mess with these. And then we have authorization, which we are inheriting from the parent, which is our collection in this case. And here in our collection, we can also set authentication, as you can see, all types that we need. Now we also have pre-request script and tests here, but we also have variables. And here is where that variable comes into play. This is the variable at my level of my collection, as you can see. But there's also a URL variable pointing to hexpert.com, and it says scope environment. Now if you look at the top right of my screen, I know it's a little bit hard to see, but here we can see that we have several environments, for example, production and sandbox. And if we take a look at that, we can see that we have several environment variables, but also global variables, which go over basically all of them. So that is something that you really need to take into account, of course, that all of these variables have a specific scope, and you need to have that scope in mind. Now, with that being said, of course, once you have your collection set up, you can literally play a whole collection. You can click run. You can see what you want to run. So once you have your security testing set up properly, you can literally keep running it over and over and over again. And you can even put data in the request itself from a file. You can save the responses if you would like to, keep variable values and run the collection without using stored cookies or WIF, but you can also save them, of course. Now if I run this, and I'm gonna run this real quickly. As you can see, the request does not have any tests, and it returns a 200 OK. I did not save the response, so I cannot view anything here. If I really want that, I can do a new request where I save the responses, and now I can see that I do have a response in here if I export those results at least. So that is my first request. Now I can also run a complete, of course, complete, like you can see right here, a full collection. Now in here I also have, for example, variations, a successfully created person and a invalid request. The body is gonna make the difference here. Body says it all. So as you can see, I can register right now. I can send off this request. I can send it off. There we go. Could not send it because connection is refused. That server is simply not online anymore. That's the reason. But this is how you do all of that stuff. Now we can add different types of bodies as well. That's one thing I still have to say. And then of course we also have APIs, which we can add if we want to work in a workspace. All of this is in the scratch pad is what they call it. This is like a workbench, but you can also have a workspace where you can save all of that stuff. If you're, for example, doing a pen test, you make one workspace per pen test, you export your workspace, you give it to your client. Your environments, up next, we already looked a little bit into those. All we can add here is our URLs. Mocks, we can add mocks if we need to. We can add a monitor which continuously runs a specific collection as often as we set it. and then a history of the specific requests. Postman is a beautiful tool, my friends. Don't forget to save. When you make an adjustment in a variable, like I do right now, don't forget to save. Little button right here. If you don't save, it's not gonna work, my friend. It's not. You're gonna have a bad time, believe me. It took me many hours sometimes to figure that out, but as you can see, once saved, it goes away, and then it's, of course, you can use it in here. The problem is, if I don't save it, it's valid in here. So if I make a change in my request itself, it's valid in that request. Seems like everything's okay because it's valid in there, but not in other requests, of course, because it's not saved yet. Alright, that's about it, I think, for Postman. We're gonna do some labs for you guys as well, of course. Not disappointing, we are going to torture you. Alright, let's find that slideshow button. Shall we play from current slide? Whoa, look at me going all fancy. Now what we want to do is create a Postman collection for us, my friends. We want to not invite any teammates to the workspace because the free version is limited to 3 people in one workspace. It's possible, so you can invite others, but just so you know, 3 people is the max. I want you to add all of the requests in hexpert.com/api-testing.php, and I want you to solve them. There are guides there. If you don't know exactly how to do it, I'll post a solution. But just so you know, it's not super hard. I just want you to get acquainted with Postman. Welcome back, amazing hackers, to this API laboratory. We're going to hack the Tireful API, but of course we need to install it first, and we need to connect to it using Postman. We're going to add a JWT token. You've probably all heard about that. That's going to basically contain your identity. It's like, hey, this is Wesley, and he might be a normal user or an admin. That might be in a JWT token. We're also going to look at some information that's being disclosed that's not correct, and then some IDORs with some SQL injection. Now, these are not all of the vulnerabilities that I've put in here. I wanted to leave some mystery, but this should give you a big overview of what you should be doing already. So let's first start with the installation. Real simple. I gave you some commands for Linux. I gave you the same for Windows and Mac. For Windows and Mac, you can just download the desktop version of Docker. And then of course you need to start it every time you want to start a Docker instance. But again, I did it on a VPS, a smaller VPS. So for me, I had to follow the Linux steps. Now, when you've done that, when you actually have Docker running, you can download the Tireful API from GitHub. As you see here, I just included a URL there, so I'm going to go to the laser pointer. So I included the URL there that you can go to, and that URL you can just do a wget on, then unzip the master file that you grab from it, and then you can build the Docker file. Now, building that Docker file is real easy. It's just a docker build command, and then you can run it already. Now, the Docker build is going to install all of the requirements into the container, of course, and then it's just a matter of running it. There's 2 things that you need to remember here. The -d parameter is going to make it so that the container runs in the background, and the -p flag here means that one port from the container, and that's the last port, is getting mapped to a port on a local host, which is the first port. Now, this is important because if you have like a web server running on a container, it's running in complete isolation, and you need to bring it outside somehow. You need to bring that port out somehow, and this is how they usually do it. So that's basically what you need to remember. It's not a lot. Then when everything is said and done, when your Docker container is started up, you should run it, and you should be able to connect to it real easily by going to the IP address that you're running it on, in my case my private server, and then actually going into the port number. Now you guys can come onto my port as well, onto my website, and try to hack that API. I don't mind. I try to keep it online as much as possible. But if it's not online and you want it online, just send me an email and I'll put it online for you. It's not a problem at all. Developers, they did not give us a Postman for this specific API, so we'll have to create the calls ourselves. It's not that hard. We actually basically just want to make a collection, like you see right here. I named it Tiredful API, and then I made a GET request in there. Now, as you can see, set the correct HTTP method. That's really important. You might be struggling with finding what's going wrong. Well, sometimes it's just a matter of setting the HTTP method correctly. That can take me a while to figure out sometimes. As you can see, my server and my port are both variables. That's important to me because if they change, I only have to change them on one port. And here I already changed the IBAN number to something more sense, like this is a real IBAN number. Now, I want to trigger some sensitive information exposure. So what I can do is actually do something like here and insert an empty array or an empty value into the IBAN number. And the program is not made to handle that. So it's going into this crash mode and it's returning a stack trace for us. That's what we want. Usually, as a bug bounty hunter, you're not going to report this stack trace, of course, but it might give you some information for later on how the program works, what's in it, all of the classes and all of that stuff. So it's definitely useful for us. As a pen tester, I would report this because stack trace, of course, gives hackers information, and that's something companies do not want. Now, as for IDORs and the JWT tokens that come with them, because we need to authenticate ourselves before we can actually grab something from this URL. Now, that's easy enough. You can just go to the user token section here. You can fill in the name. I took Superman, and then you get this token. Now, this token is something that we're going to need to fill in at the headers in the insecure direct object reference. It's a header, authorization header is what it's called, and it's really easy. You literally just set authorization headers, and then you say bearer. It's always important to have the bearer in front of it or it's not going to work, and then the JWT token that you got from the system. Now, if you do that, that's actually user 2 that you're logged in with because you're logged in as Superman, but still you're getting user 1's total marks and a score. That's not good, of course. So that's where the IDOR lays in this specific instance. Now, we have another call as well, a post call, which is the third call. And this one is also pretty interesting, going to add the bearer header again. In this case, I'm just going to change the body type from text to JSON because, of course, I want the application, the content type to match what I'm actually sending in, or the server is going to error out on me. So I changed it to JSON and I get my result, of course. Now, if I send a single quote in there, then I'm going to get a SQL error, which is going to dump a lot of the tables. It's already going to tell me quite a lot, but of course this is probably the point where you would let SQL map or something loose on this specific call. Now, that's about it for this lab. I'm not going to spoil everything. There are a few more challenges that you can do. And there might be another video or challenge about the REST API GOAT, because it's also a really cool one. And there are some tricks I want to show you there. And thank you very much for watching, everybody. And I will see you in the next one. Bye bye, amazing hackers. See you later. This, my friends, this amazing hackers, this can be your freaking API. On fire, explosive, and completely gone and wasted. Do you want this? No, I don't want this either. But I do love seeing this shit, and I do love seeing APIs suffer. I know I'm a bit of a maniac, but guess what? You have to be in this field because we are competing against each other. You, me, everybody, every single person in this field is fighting against each other, because we all want the same thing. We all want to be the best. We all want to be pen testers, I believe, or something similar. We want to be something cybersecurity related. Well, guess what? Everybody who is in this stream today wants exactly the same thing as you. It's something that we all share here, and I'm going to be very, 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 very blunt here. If you are the kind of person who thinks, oh, I'll do this tomorrow, if you are the kind of person who is like, oh, I'm going to be lazy, I'm just going to be sitting in the couch, I'm just going to chill all day and night, well, then maybe you are not going to get in front of other people who are grinding. And it might sound stupid, it might sound like a lot of people tell me, Uncle Ryan, you need to chill a little bit sometimes as well. I know I need to chill, but how do you do that when there's so many people out there grinding while you are sleeping? Like, I don't get that, I don't understand that. So I'm glad you're all here. I would advise you to take notes while I demonstrate, and this is going to be recorded, so you can all watch this as well later on if you so desire. So there are going to be exercises. I again encourage you just to watch. I'm going to be showing you some source code, I'm going to be showing you some demonstrations, and I'm going to talk about the OWASP API top 10 itself. So let's talk about it. First of all, when you have questions, note them down, take a pen, take some paper, note your questions down, because we will have a Q&A for you at the end. But we should start with broken object level authorization. And you don't need to take notes of this, because we will distribute the lesson material for this specifically to you later on. The object level, broken object level authorization, what does that mean? We have an object. An object can be a user, it can be an invoice, an object. We know the concept of object from programming languages. Well, these objects are often marked by identifiers, and the savvy of you will already know where I'm going with this. IDORs, it's a very similar thing to IDORs. This is common in API-based applications because there is a big reliance on client-side parameters such as object identifiers. This is most common and impactful attack on APIs, at least in the new release candidate, and it's going to show some authorization. Let me switch scenes for a second. There we go, so you can watch along as well. It's the most common and impactful attack on APIs, and it causes a lot of unauthorized information disclosure, modification, or even destruction of data. That means get, post, put, delete. These can all be vulnerable. Keep that in mind, because the request method can matter. It's never enough if you're designing APIs to simply compare the user identifiers with an identifier parameter to solve broken object level authorization in and of itself. The attack scenarios can range from e-commerce, revenue data exposure, to unauthorized access control of vehicles or online documents. Can be any type of object. This is on object level, and there's a broken authorization. Preventable measures for this include implementing proper authorization mechanisms using random and unpredictable values for record IDs. So that means just not sequential. ID is 1, 2, 3, 4, 5, but like a GUID, for example. And writing tests to evaluate the authorization mechanism's vulnerability. We have several tools we can use for this. We can use Auth matrix in Burp Suite, for example, or we can use access control extensions in Zap. We can also use Postman and even Postman collections with monitoring on them, and even Newman through the command line. If you're interested in that, I would recommend you joining one of our other boot camps, which is going to give you a fantastic demonstration of all of these tools. For today, I will mostly be using Postman, but if you're watching this after the fact, I would also recommend that you just download Postman real quickly, pause this video, and then go with the exercises as we make them. I have made the APIs publicly available that I will be showing today. You can simply go to labs.hexpert.com. Here you can find an APIs folder, and here we have the OWASP API 10 broken object level authorization. So let's start with that, shall we? First of all, we're going to show you a little bit of a file, which when we're started, we're going to have two pieces of sample data, documents from Alice and documents from Bob. we can find users by identifier, find documents by identifier, and we have different routes here that make use of these functions. One of these routes is going to go to the user documents get, and it's just going to grab these documents. The next one is going to delete a specific document. Here is where BOLA exists. Broken object level authorization vulnerabilities occur because authorization mechanisms have not been implemented properly. Basically, anybody can execute these delete methods, and that's not something we want. We also have the creation of a document for the same users. Again, we have problems there because it's not properly authorized, and we can make an endpoint to update a specific document in here as well. And here we have the update of the document, which is not supposed to happen. So if we start that up, I'm just on my server right now. I will navigate to the correct directory, and there we will, so OWASP, there we go. We will start up these APIs. You can just download these Python files. If you don't have a specific extension, don't worry, just type pip3 install. So if it gives you a specific import error, just pip3 install that specific module. Right now we should have everything installed though, because we've tested this beforehand. And here we go. So we will start with that space copy. That's a backslash space copy. There we go. I have, yeah, of course, Python 3. Good job. There we go. Let's remove that real quickly so we can start our Python server. It's written in Flask, and we get a IP address that we can navigate towards. But we don't really know what's going on. Luckily, we have the source code in this case. How can you find this out? Through exploration. That would be a good way to find this out, but you will see later on we will look at Swagger as well while we are on it. Now, first of all, we need to, of course, replace this integer right here with a user identifier. So let's do that. Here we can see these documents. Now, let's do that in Postman, shall we? So here we can make a new collection, and we're going to name this collection API Top 10 2023. Here in this collection, we're going to add a request, and the request is going to go towards this base URL. And of course, we have the documents as well. Mind you, it's HTTP. And if we send this GET request, we see that we do get Alice's documents. But what happens if we, let's go back here, we have our API documents. We have a delete method as well for a document ID. So let's just give that a little bit of a whirl, shall we? API documents 1, and let's just delete this, even though we might not have rights to it. Documents not found. Let's see what documents we do have. Doc1 is the correct identifier in here, so we simply replace that. And there we go, document deleted successfully, BOLA executed. Now let's save this request and let's copy it. We're going to rename this to delete doc from AO1. And we're going to copy this. So we will just duplicate it. And here in this copy, we're going to get a post going. So here we see method not allowed, but we did have that put, remember? Let's give that a shot. There we go, document not found because we have deleted it, of course. Let's go to the second document, document updated successfully. Let's save this. So we already have 2 basic requests which are giving us big problems, but we have more here, more of an example for you. So in this API, we can see that data is stored in the JSON right here. In a real API, this would come from a database, but let's start this API up and see what this API has for us. So let's just go and whoop, there we go, and start that up. Now we will do that by just adding our little bit of dash. Nope. Authorization dash 2.py. There we go, and we should have the same base URL. Now we'll just copy this though, just to make sure we have our separate requests. And here we can see that we have a data/int record ID. So let's just make that request. We should make it into a GET request at this time, and we will get the data for person 1. It says we are not authorized to get that data. Now, in this case, there is a problem though, because I told you about that user ID shouldn't equal record ID. Well, guess what? We can add a request header user ID in this request. So let's go to the headers. Let's add a new one, key user ID. I think we are grabbing person 1's data, so let's grab it. You are not authorized to grab this data. Oh, that is of course correct, because we don't have the correct user ID for us. Where is it? So user ID is a record ID, and the record ID is this, and user ID should be this. It should work, but in this case my lab is giving me some troubles. Not a big problem, you get the concept. I'm going to just save this right here, and we are going to move on to the next section because we don't have a lot of time, but I'm going to leave that up to you. There are solution files as well, of course, if you want to go through, but we have the complete source code, so we shouldn't even need them. Now, what is API 2 2023 say? We are talking about broken authentication here. This is authentication in APIs, which is often complex because you can have two APIs where the first API passes authorization controls, but the second API in microservices might not respect the authorization controls particularly well. So it's either a missing of the mechanisms or a misimplementation of the mechanisms that's going to cause a problem, especially in very complex architectures. This is particularly bad because an attacker can gain control of a user account, read personal data, perform sensitive actions such as updates. It's a big mess. Public-facing APIs are often vulnerable if they permit credential stuffing. If you don't know what credential stuffing is, everybody has this habit of using the same username and password on many different sites, and if you have that habit, please don't do it anymore. This is not a particularly good habit because that way sometimes these passwords, usernames get leaked, and since you're using the same username password on every single website, attackers will try your username password combination if they're performing a brute force, and that is credential stuffing. Weak passwords are very similar. It's just you having password 123 welcome 1 or your name of your company underscore 2001 in the password. And why do I think 2001 is particularly bad one? Because 2001 indicates that that password is now already 22 years old. I think you can see my problems. Also, a problem can be that token authenticity is implemented but not validated properly. Microservices are really vulnerable to this if they have predictable tokens, weak tokens, or have no proper authorization and authentication controls. Authentication, I should say, of course. I always mix them up. In examples, a text scenario can include bypassing rate limits on GraphQL query batching and taking over the user accounts by updating their email addresses. Prevention can include understanding all authentication flows properly using standardization mechanisms. MFA is also a good one, and it's important to note here that not all factors of authentication are shaped equally, and protecting against brute force attacks is also a big problem. Referring to the OWASP authentication cheat sheet and other resources for best practices is always a good idea here. Now let's give a little bit of a demonstration. We have two items here, two labs, and one isn't going to work. I know that, but one is. I'm just going to go to the one that is going to work now, and this one is just for illustration purposes, but I did want to show you why is this never going to work, because the generate token is not implemented. That method isn't implemented, so if you want it to work, you can just implement something that returns a very simple token. For example, def and then generate underscore token with a username, and you can just say return I don't know, token, yeah, a token, there we go. and that should work. That is your token being generated. Now this lab should work, but it's not the main focus. Here we're going to grab the username and the password from the request body, and the authentication says if your username is admin and your password is password. That is a particularly bad example, but believe me, it does happen in production systems. So that's a big problem, of course. But let's look at our lab that we know works for sure. In our lab that works for sure, we can just start again with going to Python. Let's just start a new command, Python 3, and we are going to go to do this time .py. I think, yep, that's the one we need, and we will start up our labs. Now again, we have a API here. This API runs on a port 9874, and here we have Swagger for the first time. We have API documentation, and that is particularly nice because that means we can import things in Postman. We can grab a link, there we go, API docs, have it import. Oh, of course, because we need to still add the proper API spec URL behind it. Error fetching data, that's not a huge problem, we will look at that later, but oh, here we go, continue, there we go, import. I'm a moron sometimes, forgive me my friends. There we go. So we have the creation of a new user. Here we have the base URL. The base URL is a variable that is on the scope collection, so on the collection scope, I should say. What is the collection scope? That is over here. Here we have variables with base URL, and in this case we have a base URL of this, and we are going to put that in the persistent value as well. And now if we do make a request, we need to save this, of course, but if we do make a request, we can see that a user is successfully created. We have a username with a example in it and a password. Now we also have some secure endpoints in here, and we can make requests to it. We say unauthorized access here, and here we say, for example, we have root as a user, unauthorized access, that's okay. Let's take a username that we did create, unauthorized access still. Why is that in this particular case? Let's have a look at the code, shall we? So if we look at that secured endpoint, it says login is required. So for these both, we're going to have to log in. Not a huge problem also for this one, but we don't really have a login method right here. Login method not available. So we have secure endpoint right here, secure endpoint with parameter. We have a sign up as well, and from this sign up we get just username generated. We don't have a login system here. Not a huge problem because we do have two users in here, and guess what their username and password is? Their username and password is password 1 and password 2. So that's in this case going to be the issue, and we do have this verify password in here, and verify password is actually never really called in any route, so that is why there isn't really anything behind this. But it's a big problem because we have very weak passwords. So we have those secure endpoints, and in theory, if we had a login that could generate us a proper token, we could break in with username password 1, with user 1 and password 1. So that is a broken authentication. Big problems, of course. Now we go to API 3, broken object property level authorization. Property level authorization. An object, we have seen this before, user can have different properties such as username, name, password, but can also have a property user type, for examples. And attackers can exploit this vulnerable endpoint by accessing object level properties they should not have access to. For example, if you have an object with that user type, but you can also have object where you have account type, or you can have objects where you have other users where you shouldn't be able to change their properties. As long as you're able to change a property where you shouldn't be able to change that, even if you have invoices, and you should not be able to change the customers, but you can, and it's a property of an invoice, then you have broken object property level authorization. This happens because authorization in APIs often does not validate user access to specific object properties, often because these things are auto-generated. So you auto-generate you make your object with properties and you auto-generate getters and setters, but often it is forgotten that some of these object properties might not be able to write into only readable. But if the developers still make a getter and setter for it and a route, then you might have a problem, especially with auto-generated code. Unauthorized access can result in data disclosure, data loss, or even data manipulation, even data droppage in extreme cases. API endpoints are vulnerable if they expose sensitive object properties or allow unauthorized access to these sensitive properties. And an example attack scenario can include accessing sensitive user information, even if you, for example, have read where you should not have read, because we've spoken a lot about updating a property, but even reading a property where you shouldn't be able to read that property is broken object property level authorization. Preventative measures can include ensuring user access to exposed object properties, avoiding generic methods, not using generators if you have sensitive property objects, allowing changes to only properties that should be updated by the client, and implementing schema-based response validation mechanisms. What does that mean? You will have a schema which you will test your API by, and there it will say this should or should not be writable, and you can test your API by that schema. It can also give certain responses based on schemas. What does that mean? An API gives you a response, and that schema can say, hey, this response is not allowed. It will simply block it. So it's basically a firewall for outgoing traffic. Again, refer to the OWASP resources and CWE references for best practices in securing object property level authorization. Let's show you a demo again. So we have here another API. In this API, we have another user and password. That's perfectly fine. We have an authentication. So this is also, of course, a dual broken authentication. You might see that some of these often mix. So we have a route here. Let's start this API up and explore it a little bit. So let's go to number 3 right now, Python 3, and we start 03. There we go, we have that active, and we can see username and password already, but here we also have those API docs available for us. So we should just grab them and put them again in Postman. Import, link, and we have what we need. Import as copy, because it is the same name, of course. And here we again need to replace that base URL to, where is it? Here we go. Variables base URL needs to be replaced. And we can go. So we have a put for updating specific videos with a body and a description. Here we have a response, or we don't have a response. And if we have some problems with the response, we can always look at what the request is. So we can see that the base URL is not filled in correctly. If you are watching at home, pause the video and see if you can figure out why. If you're watching in the chat, please type in what you think it is. I'm going to give you 5, 4, 3, 2, 1, and it's a save button. I did not press save, and I did that on purpose to show you that you really do have to save. Now it says here unauthorized access. Why is that? Because I have no authorization headers here. So I would need authorization headers, but again, these are not particularly bad, like hard to get. But here we don't have that login specifically. So you're not really going to be able to log in. We have this here, so let's update this. And let's remove this. Now, what am I creating here? I wonder if you guys can tell me what I am making. Let's stop this, git pull, and let's run this again. Because not only am I right now creating broken object property authorization, but I'm also creating broken object authorization. I should not be able to access these videos. So yes, it's a little bit of a mix. Usually you really have to be careful. Now let's send this request again. We still have authorized, unauthorized access, unfortunately. So let's see, update videos, where is it? Unauthorized access. And it's not in here, of course it's not in here. So that's not a huge problem. We will continue, but here the problem is that this type blocked should not be able to be updated. So we have a description here. We can update our videos. For some reason it is still not allowing me to update, even though I have removed those authorization mechanisms. The base URL is perfectly fine, but that's no problem. The demonstration here was purely about that blocked true or false. You can see that we get that property, so it is in the allowed properties, or in this case we can change it. That's, oh, I know why that is. I'm a little bit of a moron sometimes. I already told you this, but there we go. Let's try and pull that code in again, and let's run it again. I didn't update it to my server. That usually helps, I've been told. So let's run this again. There we go. Now we can see blocked true. So let's say blocked false for this. And let's send it over. It's not happening. Why is that? Because it's in the not in the allowed properties, of course. Let's add that in. Blocked. There we go. Let's update it again. Save all and commit. And let's pull that on my server again, and let's execute it. So now you guys are having, or should have, a pretty vulnerable application already. This means that you should never use this as an example for production. I think that goes without saying, but this should never happen. Broken object property level authorization. So it's a pretty nasty one. In this case, let's say that it's auto-generated and it just allows all of these properties to be changed. In this case, we have this. Let's just say for prop in data, let's just do that, just put it in. It's a big problem. All right, my friends, I think it's clear where this issue lies. Again, if you have questions, don't hesitate to note them down, because we have some time to answer them after the demonstration. I'm going to move on to unrestricted resource consumption though, because this exploitation requires a simple API request and can be performed from a single computer. Even with JMeter as a performance tester, I can honestly say that JMeter plus unrestricted resource consumption can lead to some very nasty consequences. This is commonly found in APIs that do not limit client interactions or resource consumption, often going unnoticed, especially if it's only a particular API endpoint. If it's a full API, it might be a little bit easier to notice, but one specific API endpoint might be overlooked. Exploitation can lead to denial of service due to resource starvation or impact service providers' billing. For example, if you have things in the cloud and you are spinning up a lot of Lambda servers, that can be a huge problem. Guess what we can easily do with JMeter? Because while a Lambda is spinning up, and if you send another request, it spins up another Lambda. So let's just send a million requests at the same time, and let's just have some nice money consumption. An example attack scenario can include exhaustive available memory through large file uploads, brute forcing credit card activation, and incurring excessive costs due to large file downloads. Preventative measures in this case can include using container-based solutions, defining and enforcing max size for incoming data, implementing rate limits. This can also go for outgoing data, by the way, fine-tuning your rate limiting based on business needs, and adding some server-side validation for query strings and request body parameters. Also, we can configure spending limits or billing alerts for specific service providers / API integrations. What can also happen, for example, is that we make use of the Google Maps API. That can cost some money, and if we have unattended or unrestricted, I should say, resource consumption there, we can get some very big bills at the end of the month. What does that look like in lab form? In this case, we have another lab for you. Here we have a route with images, and we also have a Swagger, so we can import it again, and we can upload images. In this upload images, there is nothing stopping us from uploading an image that is massive in size. There isn't really a restriction on it. We can send massive images, we can send them over and over again. So this is a huge problem. I'm not going to activate this right now because this can literally crash my server. But I think it's clear what the problem is over here. Let's move on to the next one. Broken function level authorization. What is this? Broken access control. That is what this is, but on API level. So this exploitation requires to send legitimate API calls to endpoints that the user should not have access to. This is also known as your vertical broken access control, your vertical access issues. And here we have problems because we are having a low privileged user executing high privileged attacks. These flaws are easier to discover in APIs due to their structured nature and predictable access patterns, but proper authorization checks can still be confusing to implement if we have a complex user hierarchy and roles. So usually we have like a few roles, but some applications are very, very complex, and we have a lot of user roles. How can you test that properly? You make your own authorization matrix. Flaws allow target attackers to access unauthorized functionality with administrative functions being key targets, and to assess vulnerability, analyze the authorization mechanism, user hierarchy, and different roles or groups in the application. That is that matrix that I was talking about. Just open Excel, note down all of the functionalities and note down the user controls or the user groups, and then say should they have access to that or not in CRUD scenarios. Example attack scenarios include creating an admin account with maliciously crafted invite and accessing sensitive data through an unprotected admin endpoint. Prevention measures include having a consistent and easy to analyze authorization module, denying all access by default. So you have basically a whitelist based access control. You only allow traffic when it's allowed, literally explicitly allow it, don't allow everything and deny everything else. Reviewing API endpoints for function level authorization flaws, and implementing authorization checks based on the user's group/role for administrative functions. For this, we should again refer to the OWASP resources and CWE references for best practices in preventing. If I look at the code again, we have a very similar code with a login manager. In this case, we have two users, user 1 admin and user 2 is a normal user. And here we have login, route, and we have a API admin user all. So here we have a GET request, which is supposed to be only for admins, but here we haven't got the access control implemented properly. So here we say if this user role isn't implemented properly, we are going to not return any data. We will return error unauthorized access, but you know what we do? We remove that right here because we're a little bit nasty. So in this case, we have a big problem. Of course, you cannot remove this code in production. It will be removed like this, but it's simply for demonstration purposes. So here it will simply grab all of those users, even if I'm not properly authenticated. Now, what does that look like on the server? Let's start up the script itself, Python 05. And let's have a little bit of a look. So pip3 install. There is one of those issues that I saw before. So pip3 install, because I'm running with Python, of course, Python 3. And then we should go to 05. There we go. Now we have this running on another port with /API docs open again. Now I'm going to work through these API docs because here we have that endpoint. If we try this out, we get nothing. List of all the users, we don't get anything. So we execute it, curl, our response is going to be unauthorized. So we don't have any access to this. We don't have any credentials here. Now what do? We do need to have credentials, of course. How are we going to edit? We just need a header here. Here it's going to see if you're authorized based on that /login route. but you can see that it's not really documented in this case. So let's do that. Let's go to this URL and then go to /login. How can you find this? You can find this through discovery. Again, really easy, or it should be really easy. Now here, if I log in, there I can see that I just need to enter my user ID. User ID 1 has access to everything, but user ID 2 says unauthorized access. I wonder what happens if we push our code changes to the server and we restart them. Let's try that again. There we go. User ID 2. Oops, still unauthorized access because we didn't pull the code, we just restarted the script, of course. Now let's pull our code and then restart our script properly as we should. And now we see that we do have access even with user ID 2. User ID has access where he should not have. Broken function authorization. I hope that's clear. I hope you can still follow, because we had broken function level authorization, we've had broken object property level authorization, and if we go all the way back, we have broken object level authorization, but also broken authentication in the middle of it for fun. Let's go to server-side request forgery number 6. Here the exploitation requires attackers to find an API endpoint that receives a URI as parameter and access the provided URI. So the server is going to make a request in our name. URL parsing inconsistencies are well known for most common programming languages, built-in functions and libraries. Server-side data retrieval is often not logged or monitored, so if your server makes a request, often it's not logged or monitored because people think it's an internal resource. Successful exploitation may lead to internal service enumeration, information disclosure, firewall bypassing because you're already in the internal network anyway, denial of service attacks, or the server being used as a proxy to hide malicious activity. SSRF flaws occur when API fetches a remote resource without validating the user's supplied URL. Modern application development concepts and technologies increase the prevalence and danger of SSRF. The risk of SSRF cannot always be eliminated, and think about especially complex architectural diagrams. There we have often a big risk because you have servers making requests to internal servers, and if user data ever gets inputted to a URL where the request is made, that's a big problem. We need to choose a protection mechanism based on the business risks and needs. An example attack scenario can include a port scan within an internal network using an API endpoint and exposing cloud environment credentials. Prevention measures in this case include isolating the resource fetching mechanism, using allow lists for remote origins, so by default blocking all remote origins and only allowing those specific ones that you have in mind, but that can still give internal port scanning, of course, URL schemes, ports and accepted media types. Disabling HTTP redirections and using a well-tested URL parser, validating and sanitizing client-supplied input data and not sending raw responses to clients, always having something in between. So even if they get SSRF, it might be blind and a lot harder to abuse. Back to the code, how does that look? We have here a Swagger again that we're going to use. We have HTTP and HTTPS as allowed schemas, and here we can see that we have allowed content types with a max size in this case. So in this case we don't have problems with unrestricted resource consumption, but we have other problems because we have a route for fetching images, and this fetch image route is going to grab images, but it's just going to make a request with a specific URL that we have provided and then save that image. The biggest problem though is that it never validates that request or that URL specifically. So here we see that if the URL is not in the request, then we have a problem, but otherwise it's just going to try to execute that request and then return that to the user. So here we can see f.write chunk, and we have the image fetched and successfully saved. So we are making requests on behalf of the user. Big problem can be, of course, the user does have to have good internal knowings of the network. When it comes to security misconfigurations, we know that quite a lot can fall under security misconfigurations, where an attacker, for example, can look for unpatched flaws, common endpoints, or unprotected files, and directories to gain authorized access or knowledge of the system. Security-based configurations can happen at any level of the API stack and can be detected and exploited using automation tools. Security misconfigurations can expose sensitive user data and system details, potentially leading to full server compromises. Think of a backup, for example, being available. Can be a security misconfiguration. Vulnerabilities can arise from messy security hardening, outdated systems, enabling outdated or unnecessary features, having ghost APIs in production, discrepancies in request processing, missing TLS, improper cache control directives, and missing or improperly set course policies. An example attack scenario can include executing malicious code, in this case, due to insecure default configurations of a logging utility and leaking private conversations due to missing cache control HTTP response headers. We can also have some preventative measures for this. For example, we can restrict the use of HTTP verbs, that is your request method, of course. We can use TLS. We can force TLS, we can implement proper course policies, we can ensure uniform request processing, and we can define and enforce API response payload schemas. If we look at security misconfigurations, well, my whole lab is basically an example of that. But here in this specific example, we have a user that can register. The user can register with an email and a password, and we are going to return if the user has successfully registered or not. Here we don't have any validation on that email though. We see that we have some parameters, username, password, but this is just to describe the swagger. We can make a post to this and it never really validates the email, it just registers. That is a big security misconfiguration, of course. And of course, I went to the next one already. The security misconfiguration is extremely broad. I think most of you can see that already. Here we have another example of security misconfiguration, the actual one where we just grab the image, but here we have the misconfiguration of using the wrong SSL context. And we also have in this configuration, let me see that I just get the exact right one. Yep, exactly. So we don't have the right response headers in here. That is one that I should mention as well. Those response headers are a huge misconfiguration error, of course. Now you already saw a little bit of number 8, lack of protection from automated threats. Now what are automated threats? Think of ticket scalpers, for example. These automated threats exploit sensitive business flows and APIs and can cause harm to businesses throughout excessive automated access. Traditional protections in this case, such as rate limiting and CAPTCHAs, are becoming less effective over time as attackers simply employ botnets and other methods to circumvent them. Right now there are also really good OCR readers, so simple CAPTCHAs don't work. We have to go for really advanced CAPTCHAs, but even those are becoming crackable by bots now. Vulnerable APIs expose business-sensitive functionalities without considering the potential harm from excessive automated threats. OWASP automated threats to web applications cover different types of automated threats and their impact. Example attack scenarios in this can include buying out limited stock products before legitimate users and exploiting referral programs in ride-sharing apps. So that can be, for example, those ticket scalpers. To prevent automated threats, businesses should identify flows that could cause harm to the business if used excessively and choose the right protection mechanisms. We can have, for example, device fingerprinting, where we check that the exact same device cannot access the exact same resource over and over again. Human detection, non-human pattern detection. Bots click in a very predictable way, we can detect that. And blocking IP addresses of Tor exit nodes and well-known proxies. Secure and limit access to API consumed directly by machines, as they are often easy targets for attackers. We already saw a little bit of an example of that. Here we have no protection for registering users, so there's no email verification, not only a security misconfiguration, but also a lack of protection from automated threats. If we go to API number 9, these are often called ghost APIs as well. These are APIs that we have no idea are out there, microservices that we have no idea of which versions of, what they have in terms of libraries, extensions. These are all examples of improper inventory management. We have no idea what our inventory and our assets look like. Threat agents can get unauthorized access through old API versions, for example, or unpatched endpoints, or by accessing sensitive data through third parties. This can happen through outdated documentation, lack of asset inventory, and retirement strategies can lead to running unpatched systems. This results in the leakage of sensitive data. Attackers can gain over the server through old unpatched API versions connected to the same database, and an API may have documentation and data flow blind spot if the purpose of the API host is unclear, documentation is missing or outdated, and there's no inventory or visibility of sensitive data flows. We've seen this documentation already. If part of it is not documented, it might be missed completely, and we have to define that documentation ourselves. There are automated generators, of course, but there might be a piece that documentation never got generated for, and that might become a ghost API, an older version API, or just a problematic inventory item. Example attack scenarios in this can include bypassing rate limit mechanisms on beta API hosts and accessing private information through poorly secured data flows between social networks and independent apps. If we want to prevent this, we're going to have to take inventory of all API hosts and integrated services, document important aspects, and generate documentation automatically. We can also use external protection mechanisms for all exposed API versions. We should always avoid using production data with non-production API deployments and perform risk analysis when newer API versions include security improvements. If we look at how this looks like, we can see that we have a login for version 1, an older version, and we have a login for version 2. And if we run this, we can see that we have usually the login 2 defined, but here we have the login 1 defined, which is outdated. We might have no idea that it's available, and it becomes even worse if we do something along the lines of this, because now Swagger documentation does not exist anymore. Outdated APIs. While we might have proper protection on the API version 2, we don't have that on proper version 1, and we have no idea. Let's move on to unsafe consumptions of APIs as the last one before we move into questions. And this is the consumption of APIs by APIs. Developers often trust third-party APIs without verifying their security. I don't know if you heard about the Colonial Pipelines hack, but they hacked a supplier of Colonial Pipelines, which then Colonial Pipelines consumed unsafe data out of. So that is often a problem in this world. They don't go directly for the targets, they go for the pieces where the target consumes their APIs, and then they attack there and they put in unsafe payloads. For example, the npm packet manager is often riddled with malicious packets that don't go detected for a long time. They seem very similar to normal packets, but they can cause problems if they're consumed unsafely. Common security weaknesses include weak transport security, authentication authorization, and input validation and sanitization. Potential impacts here include exposure of sensitive information and various types of injections, because an API might be vulnerable if it interacts with other APIs over unencrypted channels, does not validate and sanitize data from third-party APIs, blindly follows redirects, or lacks resource limiting and timeouts. It might ingest some unsanitized data, and it might cause problems. For example, there's injection attacks, and it can even lead to SQL injection, NoSQL injection, command injection. There are many types of injection attacks that we're not going to go too deep into here. So if we want to prevent this, we can assess which API security posture we need of our security providers, ensure secure communication channels so that we only consume over TLS, validate and sanitize data from integrated APIs, and maintain an allow list of known locations for redirects. how does this look like if we check it out right here? So we have an API to make a quote. This is going to fetch a quote from quotable.com.io, and here we are not checking any of the data coming in. We are unsafely consuming it. I hope that makes sense, my friends. If you want to try that, the recording will be available. I suggest that we move over to questions right now, because we have gone through quite a lot. I don't know if there are any particular questions, but if there are, feel free to type them in the chat right now. Let's see. Do we have any questions right here? I don't see any particular questions. If you do, don't hesitate to contact support at thexssrat.com either. I'm terribly sorry about the microphone scratching. I know it's not the best quality. I would like to end with one note. If you guys would like to join more of our boot camps, we also do sometimes weekend-long boot camps. And we do boot camps which are sometimes even a complete week long. I will send everybody here a discount code. If you have questions, mail them to support@thexssrat.com. I'm going to end here. These labs will stay online. Everybody will get a link to this as well, of course. So we have the OWASP top 10 item. I'm going to put that link right here. And I will also put the link to the labs right here, because that might always be interesting. There we go. Thank you very much, my friends. I really appreciate your time and everybody being here. And I will see you in the next one. Bye, amazing hackers. Much love. Hello, amazing hackers. Hope you're all doing well today. So we've made a login page to demonstrate number A2, which is going to be in here. There's several examples of these attacks, but the one I've chosen is that there's no CAPTCHA in here in my login page. This is, of course, going to allow bots to try and attempt to log into my system. That's not something that you want, so that's one of the examples. Of course, there should be rate limiting as well that would prevent credential stuffing. There's a lot of things that you can do, but of course in the article you will find a full guide of the things that can happen. But I wanted to show you real quick how it can look like. No CAPTCHA, for example. This is one of the A2 examples. Thank you very much for watching, amazing hackers. I hope you enjoyed, and I will see you in the next one. So if we do this properly, of course. Hello, amazing hackers. Welcome back. So A5, as you can see here, right here, broken function level authorization. It's a very vague one because, of course, there can be a lot of things that fall under this one. Now, what the basic gist of this is that humans are pretty predictable. Let's just leave it at that. And they might need to create something which should be openly accessible, but should not be easy to guess or should not be easy to see. But still, humans will be very predictable in their patterns. So in here we have an all books endpoint. This is our documentation, and this all books endpoint points us to the books as expected. And they also have an /admin endpoint. Now, of course, a lot of people are going to try a lot of things. They're just going to try /resources/admin. They're going to try /v2/admin. And of course, those are very valid strategies, but what we actually need here is, since they're working on a new version of the API, we need version 3, as you can see. So this brings us to the admin endpoint. Now this gives us a bad request at the moment, because we're not sending the right request type. We should be sending a post request to this one. But this is basically the gist of it. We have a hidden endpoint which should be non-accessible to us. We should be getting a 403 unauthorized, but instead we can create a request. It's telling us bad request, which is expected. in this case, because of course we don't have the correct parameters or not making post requests, we would have to dig a lot deeper into the documentation for this, or we would have to try a lot of things ourselves, like some parameter guessing or brute forcing. So this is basically what I wanted to show you guys, is that for your broken function level authorization, basically means that you shouldn't have access to this, but you do. So basically broken access control, but in the API flavor. Thank you very much for watching, and I will see you in the next clip, which is going to be A6, if I can stop my recording properly. I keep having this problem, terribly sorry guys. See you in the next one. Hey, what's up you amazing hackers? Hope you're all doing well today. So first of all, today I'd like to talk about the OWASP top 10, and we're going to talk about A1 specifically. For this I've prepared some code, as you can see here. I'm going to enlarge it a little bit. We have two endpoints, the /API/v1/resources/books and all. This is a resource to get all of the books. If we go to our Postman script right here and remove this identifier, this would be that get call to that specific URL. So as you can see here, we have a get call, but it says, we have to add all/all, of course. Now we see that we have some forbidden books, 1 and 2 are forbidden. Now we want to get those books specifically, so we can also do a get request to a specific book. And as you can see, we can get that book then. Now the thing is that if we're going to do this, we're going to see forbidden a lot, because you can see here, it's just not going to work. We're not going to see what we need to see here. To see what we actually need to see here and to trigger our broken object level authentication, we're going to actually need to change the method to host, because of course broken object, the object here would be my book, and since there's a broken authorization on this object, that means that I'm authorized to see an object which I should not be authorized to see, as you can see here. So that's the explanation for A1. There are many different ways you can test for this. It's also known as IDORs, but of course in the API terms then. So if you want the code, if you want this specific example, there's going to be a coding example as well in the article. It's just a Flask example, really simple. You just install everything that's required, all of the requirements that are in the imports. You do pip install, and then you do Python, and then you do the name of your program. But it's going to be in the guide form as well, so if you want to try this for yourself, it's possible. This is how we do broken level authorization, or at least this is one of the possible examples. Thank you very much. I will see you in the next example. Hello amazing hackers, hope you're all doing well today. Welcome back to A3. So in this example, we're going to see excessive information disclosure. And what do we mean by this? There's an UI consuming this data from the API, and the UI is showing the credit card number, the user, and the validity date, which is something that's expected. The user is trying to look at their credit card data, but they should of course not be able to get their CVV. Now the reason CVC, is it CVV or CVC? I don't remember, but anyway, the reason that this is really important is because if there's a man-in-the-middle attack, this traffic might be intercepted, and even though the UI is not displaying it, the API is returning the data, which is the A3 excessive information disclosure vulnerability. Thank you very much for watching. See you in the next one, I guess. If I can quit my recording, of course. See you in the next one, amazing hackers. Hello, amazing hacker. Welcome back. Now, we can't talk about A9 without showing you guys what it looks like. So here it is. I have a lot of systems in here. I have a lot of things that I am testing for APIs, and I have no management system. These are basically just random files. I don't even have a repository or anything. So of course that is a gross error, and I should always be at least having proper asset management. knowing what systems I have up and running on which ports, because if I ever do decide to use this server for real, and I have some obscure thing running on port 10 or something, then I'm going to need to know. So that's what asset management is. I really need to know exactly what systems I have available, and I need to look at them properly, need to look at their version numbers and all of those things combined. So thank you very much. That was it for this one already, and we should move on to the next one. See you later. Hello, amazing hackers. Hope you're all doing well today. Welcome back. We're going to talk a little bit about A8 injections in this video. So as you can see, I have a very basic web page here for login with a username and a password. And this is a SQL injection that I'm going to demonstrate. I have the developer console open here because I changed the type of the input field to text just so I can show you guys what kind of password I'm using. And the SQL statement is going to read select star from users where username equals and then and password equals nothing or 1 equals 1. So it's always going to return true, always going to log in. And that's basically what's happening here as well. Very simple vulnerability type at first sight, but if you dig deeper into this, you're going to notice that injections are going to be very deep, because recently, of course, cross-site scripting joined the injections force, but you have LDAP injections, you have SQL injections, you have CSV injections, JSON injections. There's so much things you can do with the injection category, but I just wanted to give you guys an example so you guys can have a grasp of what one of these looks like. Thank you very much for watching, and I will see you in A9. Hello, amazing hackers. Welcome back. We're going to talk about A10, and I already showed you this, but A10 is insufficient logging and monitoring. Now, as for these specific APIs, I do have one log file, but it's nothing, and I also have the no hangup log files. But again, those are not really easy to go through. They're not segregated into separate log files, and I am not monitoring them at all. If an intruder tries to attack them, I think it's kind of expected on my laboratories, so that's why I'm not monitoring, of course. But you should always expect an attacker, and you should always monitor for them. It's that simple. Because now I'm just not monitoring. Maybe someday somebody comes along and he decides to delete everything from my system. I have no monitoring for that, so I would have to have some of you guys come and tell me, hey Uncle Rat, this completely broke. So that's something that I wanted to give with you, is on A10 specifically. If you do logging, do monitoring as well, because you don't want to spend all of that money on the logging part and then have it go to waste without anybody watching. Thank you very much for watching, and I will see you in one of my next chapters. Bye, amazing hackers. Hey, what's up, you amazing hackers? Welcome back to A4 now. A4 is going to be one that we've already talked a little bit about. This is the login system again. And then here we have a lack of rate limiting, which is going to allow attackers to keep on trying credentials over and over and over again, basically building a bot. And the fact that this one is also vulnerable to A2, where there's no CAPTCHA in here, that makes it even worse. So it should definitely have rate limiting in here. Every important resource, everything that consumes a lot of resources should have rate limiting. So think about which of those resources are important to you and which ones do need rate limiting. Thank you very much. This was the example, and I will see you in the next one. Bye, amazing hackers. Hello, amazing hackers. On to A5. So A5, sorry, I mean A6, of course. A6 is mass assignment, which means that if you're creating an object as a developer and you're creating the user object, for example, you might give the user a account type, and that account type might be user, normal user, because you might need administrators or site moderators or something like that. So what you'll do is you'll add the account type parameter. Now, when you're creating that user object, you might use generators, or you might be not thinking properly, and you might expose that parameter, as we see here, we have a call to the user endpoint, which is a post call, and it's going to change my user's settings. And I can put things in here which are pretty normal, like name, last name. These are all things for my account, but I can also put things in here which are really not good. Oh, sorry, I need to put it in my body, of course. So I can also put things in here which are really not good, like the user type. I'm going to open a JSON string first. I'm going to say user type double point. And of course, I forget to add my quotes, user type double point, and then I might have user as what I got back from the response when I saved my settings, saved the name change. In this case, I might have gotten back user type equals user. I'm going to copy it from my response, put it in my request, hit send after changing it from user to admin, and there we go. We have our vulnerability mass assignment, because when creating this specific user object, it exposed this user type, and even though it might never be used in the UI, even though it might never be visible, not even in a hidden parameter or anything, if it's visible in the response, you might be able to copy it over and you might be able to change it, which shouldn't be the case. That's going to be mass assignment. Thank you very much for listening, and I'll see you in A6. Welcome back, amazing hackers. Hope you're all doing well today. This is going to be A7 security misconfiguration. And for this one, I'm going to keep it very simple, going to look at one of my previous challenges. As you can see here, we have a debug set to true, which means that you might be able to connect remotely to debug this. This is not good, of course, and we should always put debug to false. Simple as that. That's it for this one. Thank you very much for watching. Sorry it's a bit short, but I will see you in A8. Hello everybody, hope you're all doing well today. Great seeing you. So today I'd like to take a moment to talk about API security. As we move on in our day and age, there are new APIs popping up every single day, and of course there are new hackers popping up as well. These threats are something that we have to take seriously, because they can cause serious reputation damage. And of course, there are many different ways to handle these threats. We can harden our APIs against these attackers, and there are several different ways that we can do that. We can do that close to the source by protecting our APIs themselves, by protecting our applications. We can do that by, for example, using input sanitation. We can do that by obfuscating certain things like our JavaScript files. And those are all things that can deter attackers, definitely. But if we really want to be secure, we can never rely on one system alone, of course. And as we implement more and more security measures, there is a cost connected to that. Nothing comes for free. That's where API firewall comes in. Now, what this tool does, first of all, is it's free. That's something that not a lot of other web application firewalls have, but it's also very lightweight, allowing us to not go too deep into, not spend too much resources into inspecting our traffic. Today, I'd like to take a moment to go over installation of this specific tool, but also what all of these environment variables are and how we can use them to our advantage. Now, there are a couple of things that I'd like to highlight specifically, and we'll go through them as we move on to them. Let's first of all start by installing a demo API, because of course we need an API that we can test on. We need something to protect. So what the fine folks at Zalando have done for us is they've created a connection API, and this API we're going to use in our case for testing our firewall on. And for this API, all we have to do is install the pip requirements. So we'll do that with Python pip, and pip is basically a package manager for Python. So as you can see, when we type the command pip install and then our connection manager, we can see that we have Jinja installed, markup save. So all of the different requirements that we need are going to be installed with this one pip command. Very useful. When we have that installed, of course, we're going to change into our temp directory, and then we're going to clone the specific API demo. So this is the code itself for the API demo, and we can notice that ourselves as well, of course, if we move into the temp folder and then into the connection folder. There we have a couple of folders. One specific one that's interesting is the example/OpenAPI folder. If we look in here, there's a couple of files that we can see that are important. In this case, we want to move into the method resolver directory, and in here we can see that we have the app.py. Now app.py in our case is what we're going to use to start our application. As you can see, as I'm typing Python app.py, when it executes, of course I meant Python 3 app.py. There we go, now my app is starting up, and then you can see that it's running specifically on this IP address, on this specific port. So that's where the API is running at this moment. I'm going to kill it for now, because I'm going to set up my API firewall as well. That's something that's very important. So what I'm going to do is, of course, I have Docker installed already. It's important that you have that installed. If you don't, on Linux, it's a simple sudo apt-get install docker.io or yum install docker.io, of course, depending on your flavor of Linux. And then if you have Docker installed, you can simply do docker pull velarm/API firewall. Now, as you can see, I did this live on stream and it happened very fast. So that should be a first indication of how lightweight this WAF really is. Now, of course, from this specific docker pull command, we need to set up our container, because now we have a Docker image, and what Docker is going to allow us to do is it's going to allow us to take a configuration file, that's what we call an image, and it's going to build a container out of that. And that container is what's going to run our API firewall. So that's very useful because it's going to make our installation extremely fast. Now that we have our Docker API pulled, now that we have the API firewall pulled, I mean from the Docker hub, we can actually run it. So I'm going to use this command for that, and I'm going to go into the specific flags later on. First of all, I'm going to run my Docker container. So we have that running now, and I can check that by typing docker container ls. And there we can actually see that I do have my container ID here and the specific image that I'm running with the command that I'm running it, when it was created, and what the status is, on what ports it's running, and the names that it's been given. So for that, I know that my Docker container is now running. To check the logs from this specific Docker container, I can go docker logged, and then I can look at, of course, I need to take that specific Docker ID. So let's do docker logs and then copy the ID that it gave us here and then paste it behind here. And now, as you can see, we see that we show the logs for that Docker container stating what specific parameters were used. So here we can see where the API specifications have been specified. This is really important. And this is the temp folder of the container, by the way. This is not my local machine. This is the temp folder of the container. We'll get more into that later. So as you can see, we've mounted that specific YAML file onto the temp folder of the container, and that's where the API specs reside. And that's where we can see that we have a get call, a post call, a delete call, another get call for a specific pet ID, and a put call also on a specific pet ID. That all seems to work fine. Now on to the next step, of course, we need to test if what we have running actually works. So, we first of all, of course, we need to start up our specific application again, our API, because at the moment there is no API that's being protected. Now to do this, what I'm going to do is I want to start up my specific API in the background, because I still want to be able to check my Docker logs in the end. So to do this, I use the no hangup command. This is going to ensure that even if I disconnect from my secure shell session, that it won't matter all that much because my command will still be running in the background. And I can also use the ampersand parameter to send my command to the background. Now, as I do that, I notice that a file nohangup.out is created. I can look at that specific file later on and I can check the logs of my application that's being started up here. So as I type my python 3 app.py command, it's starting up an API and it's writing the output of the console to the nohub.out. I can also check that by issuing a tail command and then checking the nohub contents. So as you can see here, the server is started. We're seeing the same things that we saw before. I can also do a cut of that just to make sure. There we go. You can now see that I do have the entire same output as I used to before. And that's what we needed in this case. Now that I have my application running, I have my firewall running, we can try issuing some commands, of course. Now, the first command that we're going to issue is actually a curl, and we're going to try and make a correct curl call to see if this works. So if we look at the specific API specifications, there we can see some really useful things. So what I'm going to do real quick is I'm going to look at where on my local machine these API specifications can be found. Now I'm going to quickly do that to explain the find command. So I start at my root directory. I look for a name called, and we notice that here, called pets-api.yaml file. And as you can see on my local folder, it's going to be in that connections folder that I just downloaded in the OpenAPI folder of the method resolver. So we're in that folder right now. Let's move to the OpenAPI folder. And in here, indeed, we should find the YAML file. Let's cat this specific file and look at what's actually required of this API. So whenever we make a call, we can see that we have a couple of things in here. We can see, first of all, the endpoint. We can see the type of request that's being made. And then we can see the responses and also if things are required or not. For example, if we make a put request to the pet endpoint, we can see that we require, if we move down a little bit, error required, code and message, of course. So it's going to be a required name in this instance, as you can see here, tag type string red, and name also type string example fluffy. And then we also need an identifier for this. So these are the API specifications that are going to be read in by API Firewall. And API Firewall is either going to be blocking or logging your traffic, depending on what you set it to, of course. But again, we'll get more into that later, based on these API specifications. So based on these specifications, we should also be able to make up a call, which we did right here. We can see that we are making a curl command. We're issuing a curl command with the method put, a specific header in here that's content type application JSON, and then we are using the body name, and then we're giving it a name and a tag. So as we make that put request, we can see that we get a response in this case, which is good. Now, of course, if we make a put request that doesn't have a string in the name, then we're going to find an error because, of course, the API specifications specify that we need a string in the name and not an integer. Now, from our front end, we're not going to see much in this case, but if I look at those Docker logs that I had open in the beginning, then I can actually see what is being blocked and what's not. As you can see in this case, the API Firewall is actually telling me that I have an error being occurring, request validation error. The request body has an error. It doesn't match the schema. Error at /name field must be set to string or not be present. And then schema, it's telling me what schema it's using to verify my response from, my request from. and then I can see value number in integer. So this is what it was, this is what it was expecting. And then I can also, of course, see the IP addresses. That's also pretty important. The specific IP address that issued that request is also logged. That's useful later on for investigations. Now, that's pretty much what I can do. I can also try issuing a blocked command in here, like a command, a put request that doesn't have a name in it. That's going to issue the same response for me again. But if I look on the server, I can see that again I have a request validation error, but this time my schema doesn't match at name because name is missing. So as you can see, there are quite a lot of details that we can actually go into, and the logging is pretty well documented. You can see a lot of what's going on by just reading your error messages. So that's pretty cool, of course. Let's look at what we just typed, because when we did start this Docker container, we did put in a few flags as well, and I want to go through each and every single one of them just to make sure that everybody understands what we just did. So we have a -d flag here, and what this d flag is going to do is it's going to allow our Docker container to run in the background. That's really useful because then we don't have to keep it open, of course. And then we can issue the -v command, and this is going to mount a volume. That's that volume that we talked about with the YAML file for the API specifications. It's going to mount that to the temp folder. And then, of course, we have the -e parameter, which is environment variables. Now, these are variables that have been set by the API firewall team that we then can influence. These are very useful, and we'll look at all of the environment variables in a second. But for now, what we've set is the API firewall server URL, and this is the specific API that we are protecting in this case, which resides on port 9090, that, like we saw before, and also version 1.0. And then we also have an environment variable for the API specs, which is, again, this is going to be a parameter which is going to be the temp folder on the container, not on my local drive, of course. Now this environment variable is going to be used into these parameters later on, and that's something that has been done by the API firewall team for us. The request validation environment variable allows us to either block or log a response which hits the request validations. We can also do the same for response validations, of course. I usually set these to block, but it depends on what behavior you want the firewall to display. And then we have the -p parameter in here, which is going to allow us to map a specific port from the container to a specific port of our local machine. So this is going to route all of the traffic from port 8282 on the container to port 8282 on the local machine, which will allow us in turn to talk to our API. We can to our API firewall. We can of course see that as well in the curl command that we are issuing. We are talking to port 8282 and not to port 9090, although that would also work in this case if we try this. That's not going to be a problem. As you can see here, we do get a response back from this. But of course, in a real life scenario, you would block off this port 9090, and you would ideally only allow people or your customers to communicate with the API via the API firewall. So that's it for all of these specific parameters that we've given to our command. Now let's open the Docker page real quick. So let's open the API firewall Docker hub page real quick, and let's have a look at all of the other environment variables that we can use. Because as you can see, we have used this one API firewall URL, but we can also choose which log level we should include. Now, by default, as you can see, this will be on debug, but it could also be info, error, warning, or debug. So either one of those, whichever you prefer. Now, API firewall also has a read and a write timeout setting and a shutdown timeout, which you can set up as well. And then we have the specific request and response validation techniques that we talked about, block, log only, and of course there's also a disable option. If you don't want response or request validations, you can disable either one of those. As for the TLS section, you can see here that we can set up the API firewall TLS certifications path. We can set up the file and the certificate key as well. Now we can also set up the specifications. That's what we of course did before as well, where we mounted our specification file to the local temp folder, and then we're going to give that temp/pets api.yaml file as a parameter. We can also of course set up our server, set the maximum connections per host that are allowed. Then we can also set up the server read timeouts and write timeouts as well, and the dial timeouts. So this is the ping. Now, of course, there are some performance benchmarks that are in here as well. These are just to show how well it works, and we can execute these performance benchmarks ourselves as well using Apache Bench. If there's more time after the questions, we might actually execute this just to show you guys just how performant API Firewall really is. For now, I'd like to thank you all very much for your attention, and I'd like to ask if there are any more questions. Thank you very much, and I will see you soon. Hey, what's up, you amazing hackers? Hope you're all doing well today. Welcome back to the channel. So today I'm going to teach you a little bit about API hacking, about APIs in specific, and this is just going to be a little bit of a condensed version of what it's going to be like when we're going to have our 3-day API bootcamp. First of all, it's so good to see you. Please grab a seat, take your popcorn, and enjoy the show. Uh, there's a lot of people here from India. That's freaking awesome. I saw some Texas coming by as well. You guys are freaking awesome. Poland, I have somebody who would love Poland. It's let's just say that I love your guys' fireworks. Let's put it that way. All right, my friends, let's talk about APIs though, and we'll get a little bit of a break today as well, of course, after the presentation. But first, we have a few things to talk about. First of all, I am going to give away some stuff. So I'm going to give away some of my throughout this webinar, some of my bootcamp seats. There's going to be 3 seats available. That's going to be for a giveaway, and then we have some seats that are going to be Of course, everything else is all of these it's gonna be 50% off. But what I was gonna say is we're gonna have bug bounty guides that we're going to throw away. We're going to have an essentials guide that we're going to throw away. We're gonna have a lot of stuff basically, and we're gonna start with the first one, the bug bounty coupon. Let's start with giving you guys that worth staying until the end. There's 10 copies available, so I would hurry if I were you. Now, just do that while we wait. There's maybe gonna be some more people coming. First of all, I'm going to say this is also recorded, so you can watch it back. No worries if you missed something. We're going to get started with what is an API. This is material from our upcoming bootcamp, also from our upcoming certification program, because we already own CNWPP. If you're interested in that, cnwpp.net. Not going to go too deep into that right now. Don't go to the .com. Promise you, don't go to the .com. But copy is going to be the extension of that. First of all, we're going to have to start with what an API basically is. First of all, the definition. What does this stand for? Application Programming Interfaces. Fine, Uncle Red, that's amazing, but what are we actually achieving with an application programming interface? Okay, so let me share my screen. That's gonna be important, I think, if I do that. If I ever forget that, don't hesitate to let me know. There we go. So, oh, that's the wrong presentation. It's fine, it's fine. I've already given out this coupon anyway. It's fine, all's fine. You know that meme where the house is on fire and the dog's like, all's fine? That's basically me right now. So the application programming interfaces, sometimes applications are going to have to talk to each other. Like, for example, if you have an application and you want to display the weather, I have weather on my watch here, so that's fine. My watch doesn't have a weather service on it. That's not how it works. My watch basically talks to an API, and that API presents it with weather data, for example, in JSON format. And then my watch, it can display it however it wants to, depending on the format it gets. It can display that in a GUI, for example. Sometimes those apps need to communicate, but it can be on different levels. Of course, OS, web. We're going to focus mainly on web APIs right now. So I don't think I have to explain the importance of APIs in today's digital age. Everything is basically communicating through APIs. There, there's so much like happening in the world of APIs because you have people that are wanting to take everything to the cloud. You have people that are going back from the cloud. It is a different architectures that these APIs can have. It's quite an expansive world. And that is good because if you know those details and other people don't, you have an advantage over other people. It's the same as with mobile. You'll have an advantage over other people if you know mobile hacking. There's basically different types of APIs. We have REST APIs, SOAP APIs. People often compare the two, but you can't really do that because, I'm not going to go too deep into it right now, but you can't really, you can compare them to a certain level. Let's just keep it at that. GraphQL is also in there. If you've ever worked with GraphQL, it can be a database API in that instance, operating system APIs, library, and framework APIs. I mean, I'm sure that we've all had the sometimes used, well, if you're a programmer at least, you're going to have used this extensively. Let me put it that way. If you're not a programmer, this might be new to you, which is why I think it's important that we go into the basics first. APIs, at least on web level, I think on all levels basically, work on the request and the response model. So you give the request, you get a response back. On web, those use the HTTP methods that we're used to: get, post, put, delete, and we get a status code back. Okay, simple enough. Those are some basics of APIs. We have different components of an API. We have endpoints. An endpoint is going to be functionality. For example, just a function returning a calculation. That calculation will need different parameters. What's your first parameter? The second parameter, what type of calculation do you want to do? It will have headers and a payload or a body. That body is not always required, but the other ones aren't either. Like, for example, you always need some headers, but you don't need, well, let's just say that sometimes you might need headers, And what do I mean by that? Like, for example, an API key. You won't always need an API key. Sometimes you put that API key in your headers. Parameters, those are usually going to be required, but again, not always. If you're just going to request data, a list without any specifications, you can just request an endpoint and it will give you that list without the need for parameters. It's important to know the role of all of these and how they can interplay with each other. Next up, we move to authentication and authorization because I've already told you guys about those headers, like those API keys. They can be an X-API-key header or any specification how we want to call it because if we make this API, we're basically going to determine which headers it's going to check and which ones it's not. All right, so very simple. If we can add one of those headers as an API key, that might be useful. That is also why you never share your API keys. So if I make an API key, I can use that API key to then request that API, for example, for Google Maps, and I might need that for making specific requests. Now, there's a little bit of a caveat there because you can have a public API key, for example, if you use a service that is meant for your advertisements, for example. It's okay if your API key there is public because there's requests being made throughout the application, so it's a bit of a mixed bag there. As for OAuth, that's a different type of authentication. Not going to go too deep into it in this course. JWT, JSON Web Tokens, also not going to go too deep into it. The basic authentication, that's a fun one. That's just your username and then a colon, your password, day64 encoded as a header. I know, wow, fantastic, but that's just the way it is. So common use cases of APIs, I'm not going to go too deep into this. Just know that, for example, my mobile app can fetch data, web applications can fetch data. I might need to update data. There's different use cases possible. And there's also different benefits to using these APIs because if I use an API and I notice that a lot of requests are coming in and my APIs cannot handle it, I can scale those. They can work modularly, meaning that I have a module of APIs that work together that can be integrated with other modules. Time saving, of course, and again, your integration capabilities. Potential risks, I'm not going to go too deep into this. We all know that it can be a risk, but which ones exactly? That is why we're going to go into the OWASP top 10. What is important though is your API documentation and how to test APIs. Clear documentation is going to be important, and you just need to know that this documentation, and I'll show you later as well, it's usually generated by the developer. So if I don't want to document a function because I don't want it to be known, I don't document it. Just so you know, it just means that not that everything that's documented doesn't mean that that is everything within the application. We need to work with different tools to talk to these APIs. That you can use Postman there, you can use Swagger there, but even a basic curl command can help, and even just a web browser can help. Also put a link up here to Strava, to their playground. This is an example of one of those swaggers, but to be honest, we just have our Notes API, which is on 172. There we go. 172.1.5.5.5.98502. I'll also put this link in the chat, by the way. There we go. That might be useful for you guys. And I'll look at the questions in a minute, by the way. But this is basically our standard version of an API. We have some API documentation here where you can see that you can authenticate, log in, register, then create a node, get nodes for a specific user, and search the nodes for that user. Now, if you were to look here, this is basically Swagger. Here you can see all of the different parameters you are going to need, like the body. You can see the possible responses, and I document this. This is all written by me. If I don't want to put something in here, I just don't, And then I can see which response content type is possible. Let's give it a whirl, shall we? So you can click the try it out button in the top right. So go to that Notes API, please, and then click that API documentation button. Here you can go to the get notes for a specific user, for example, or create notes, I don't care. And you can click try it out. Then you get a body which you can change things in. And if we execute it, we can see that we get our curl request. We can get the request URL and we can get the response. So that's interesting, isn't it? Because if I then try out this, for example, and I want to get notes from user 0, I can see that I can get all of their notes as JSON in a response. And this might be useful because I might be building, for example, let's pretend that I am some kind of big software conglomerate, I am Microsoft, and I want your OneNote, your notes from OneNote, I want them to be available from all over the world. I can do that through API calls, and I can add a layer of authentication, which some of the astute of you might have already noticed I am missing here. I'm just missing my layer of authentication. And that's pretty bad because that is a pretty big exploit. I can create notes in other people's names, but I can also get notes from other people. So as you can already imagine, that is probably not supposed to happen because we do have that login functionality and we do have that register functionality. So as you can see, people should be able to log in and register. Now, next up, we've already looked at that API a little bit that we have here, but I'm going to talk to you a little bit about the ways of communicating with these APIs. This may sound silly, but there's different ways, and I think you should know them all because sometimes you might be in a limited environment where you won't have your favorite tool available. And everybody's always irking me about, oh, do you really need to know all of these port scanning tools? Yes, 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 of course you do. What if I'm in an environment where I only have Netcat? Then I should be able to do a port scan with Netcat. And I should just be able to do the same right here. And as you will see, I'm going to open my Termius. I already have it open, I believe. Let me just open it real quick. So here, and this server, let me clear what I have on screen. I'm going to, and then make that maybe a little bit bigger. There we go. Do we have Nmap on here? Yep, we do. So I'm going to run an Nmap scan for this server, not on HTTP, of course, just a basic Nmap scan. And I would like to have the SV for banner enumeration, so I at least know what the hell's going on that port. As you can see, probably there's going to be a hell of a lot of servers available. But for some of these ports, if I open them on this server, I might not be able to have that link API documentation. I don't always know it. Like this is very clear because I gave you a clear link to the API docs. Very simple, very clear, but it might also be a little bit more confusing where you are not sure what these API docs are. And while this thing is scanning, I'm going to start up a new connection to that. And then we're going to start up a different tool. Come on, dude. We're going to start up a different tool as well. Because of course, Nmap is fine. It's fine, it's fine. This is what they, oh, right, I'm starting up the wrong server. I need to do the new lab server, I think. It's what my boss always says. It's fine, it's fine. Yeah, my client, of course. So let's see here. Now let's see, do we have FUF installed? No, let's just install it. I'm going to fuss a little bit. And what I want to fuss for is basically I want to fuss for API documentation lists. So let's go and see if we can find a Swagger word list. Swagger word list. And look what we have here. We do have quite a few. Now let's just API docs. You can see that API docs is in here. So let's just copy the first few lines. Let's make a new file, nano, and let's call that the docs.txt. There we go. All right. And then we can fuzz this with fuzz-u. And then it's very simple. We just take the URL we know that this is on port 502, and we need to remove this HTTP again. Now, what am I missing from my command? My word list, of course. And that's gonna be the docs.txt file. I did something wrong with my command, apparently. Fav-u. Yeah, I think the -u needs to go first. That's probably what I'm doing. Oh, no. The fav. It's like this, right? Fuzz. And then dash, or there we go. So as you can see, we have some issues here. Apparently, progress 12. We have errors 12. Okay, so that didn't go quite as expected, but I'm trying to give it a little bit of a fuzz here. Oh, of course, because I didn't give it HTTP. Duh, Wes, come on. But this is basically the way you can fuzz your API documentation. So this is important to know that you need to sometimes do this. If you find an API, this should basically be your first action, trying to find that API documentation. And what you'll often find is that you'll have something like this. Now, this is something that is very useful to a computer, but is not per se useful to a human. How do I put this into something that I can use and translate? I can use Postman for this, for example. This is just one of the many, many tools that you can use. I'm just gonna switch to lightweight client for now. And here we can, oh, right, yeah, can we import? No, that's a girl request, so I'll have to log in for a moment. Otherwise, it's not going to allow me to do that. It's a little bit of a shame that Postman is requesting people to log in now. Let's just sign in for a moment. Now again, Postman is just one tool, of course. I can use multiple tools for this, as example was given before. Just a simple curl command, and this is getting annoying around my wrist. One moment, so I can silence this. There we go. Opa, there we go. Now let's add a list from our workspace. So we pasted that URL in here, and now you can see that it is trying to make a Notes API collection. There already was one, so that's not too bad. But the problem is, the moment I try to do something like this, very simple, get notes from a specific user, and I can set that user, of course, I am not going to be able to do it. Oh, there goes something, God knows what. You can see already here that it did not fill in the base URL, which is important. You need to be able to troubleshoot this a little bit, and you see here that base URL thing. If I go to this notes copy URL and I go to the variables here, I can change this. So let's do that for a moment. Let's change that. There we go. And now let's do the request. I have an error again. Some people might know what this is, especially orgists should know what this is, but this is the problem of me not pressing Ctrl S or Command S. I didn't save, and that's a problem, of course. There we go. Now I'm able to at least get to the server. I apparently still did something wrong. To troubleshoot this, I can go to my console and I can see that I left that A in somewhere. That's not good, of course. Here we go. If I fix this, we can see that the request does go through. Very useful to import this type of documentation into something like Postman so you can work with it more easily. And what I sometimes like to even do is make a simple Python request to interface with the, what am I saying? A Python script to interface with this. And you can very easily do that these days. Please make me a Python script that can interface with this API. Simple, isn't it? It's very simple. As we can see, it creates the script for us. It's not that I like AI, of course I don't like AI. No, of course not, of course not. Never. I would never do such a thing. But this makes it very, very easy these days to work with these types of If you want a script, you just post it in, done. Those types of jobs, very, very cool. The only problem is that you might have to be able to debug because, let's be honest, sometimes ChatGPT likes to take a little bit of the right mushrooms and hallucinate up the ass. So you have to be careful with that, but that's okay. All right, my friends, let's see if there are any questions. And before we go on to the questions, I do have to say, and this is very, very important, I have Sir Hagelot the Fifth on my shoulder, and Sir Shaggle, or near me, I should say, and Sir Shagalot is very, very hard to please. He is not easily content. Just so you know, you'll have to work really, really hard to make him happy. Just so you know. Just so you know, I'm just giving you a heads up, that's all. There we go. Let's see. Can you use the tone to grab an API key? Sorry. I'll get to those questions in a moment. So nothing specific about what we've gotten so far. That's good. If you have any questions about what we have so far, just let me know. Of course, I will get to all of your chats after the presentation. I don't want to just disrupt the flow. That's why. No worries. There's nothing bad about your questions at all. I love questions like that, and I love interaction, of course. Now let's talk a little bit about the OWASP API Top 10. Oh, one of my favorites, OWASP Top 10 for APIs. Now, you may or may not like this. This is something that I love. We have the 2019 version and the 2023 version. There are discrepancies, though, well, differences, I should say. There are things the same. But one thing is very, very obvious. This is only a top 10 vulnerabilities. Only a top 10, nothing more than that. It's important that you realize that. But that being said, it is a good, like as you can see, it is a good resource for us. Now, I'll be mostly focusing on OWASP API Top 10 2019 today, and I'll be going through it in in a theoretical way. If you would like to see the really practical way, please come to our bootcamp. I would love to show it here, but I need to keep it a little bit short, of course, because I also need to go to bed. I need to get up at 6 a.m. Lovely, lovely. I love getting up at 6 a.m. But enough complaining from my end. Let's talk about the OWASP top 10. Number one. How can we get to? Well, it's okay. So this is just broken object level authorization. This is a type of broken authorization. And here we are looking at the object level. You can also do function level or property level. So think about that. If you have an API usually works based on objects. So I have an object like a note. A note is an object which you should have authorization for. If it's not there, that authorization, okay, fine, but that's broken object level authorization in that case. As function, in this case, would be, for example, let's go back to our notes API or just this one. A function would be this. So let's say that I need to be logged in to get the athlete. Just this value, I don't have to fill in anything here. All I need to do is be authenticated. So that's a function that is not specific to an object because I don't refer to an object here. A property would be, for example, if I could adjust the athlete type of other people. That would be a property level authorization issue. I hope that's clear. That might be a little bit confusing sometimes, but it is important to know that there are three broken authorizations possible on API level and potentially even more. And the fact that you'll see what falls under this, it's quite expansive sometimes. Talking about broken user authentication, what is authentication? The difference between authentication and authorization? I often ask this because it's very confusing. If I authenticate, I log in. If I authorize, I'm already logged in and I just ask, do I have permission for this function? Broken user authentication says it all. There's something wrong with that user authentication. There might not be rate limiting, allowing for password stuffing. There might be something like SQL injection in there. There's a heap of possibilities which could be for your broken user authentication. As for excessive data exposure, this is a fun one. Usually when I make an API, I also have some kind of GUI to present to the user the information that they need. Let's say that the user wants to view their credit card number. Normally, you only see like the first digit and a few of the last digits of your credit card number, but never the whole thing, right? Now, imagine that there's some smart developer who thinks, let's just put those X's there in the GUI. Let's not do that on the API level. The problem, though, is that sometimes attackers can talk to that API and then they have that data available, that full credit card number, instead of just that number with the X's on them. Big problem, of course. Lack of resources and rate limiting, that is clear, I would say. APIs should restrict the number of requests, but also the size of the requests and the number and size of the resources that can be requested. So there should be a limit basically on what you can submit for kind of data, but also what you can request for kind of data, both in size and in amount. And it should be properly configured as well, of course, because sometimes it's not fully missing, it's just badly configured. Broken function level authorization. One more time, authentication versus authorization, logging in versus checking. If I'm even allowed to do something like that, a function would be the slash applet where I'm not referring to an object directly. When I'm referring to an object directly, it would be an IDOR or a broken object level authorization. IDOR stands for insecure direct object reference in this case, of course. When it comes to mass assignment, this is a very fun one. I found a lot of issues with this. Basically, imagine that we go back to that object, to that nodes API that we had before. Here, the objects are the nodes, right? An object has properties, like, for example, let's try this out. Let's get users one nodes. A node has a content, an identifier, and a title. Let's say that I am able to, so I'm generating this object. Usually I'm going to auto-generate the object, right? So I want to be a little bit lazy as a developer. I auto-generate this object and I auto-generate getters and setters. So normally you shouldn't be able to set some of those properties, like your account type. You should never be able to change that to administrator. Broken property level authorization. That's the same as this mass assignment thing, or at least very, very similar. This is something that I did find a lot of bugs with. Just to be clear, this is something that in bug bounty hunting has helped me quite a lot, because I would just go to the user settings and I would save, and then I would see what kind of properties were set and what kind of properties would be returned in the response. And if there's any discrepancies, I would take the parameters from the response and paste them in my request. That's a good way to check for mass assignment. When it comes to injection vulnerabilities, I think that's clear, but there's just so many injection vulnerabilities. That's the problem. You need to know so many different injection vulnerabilities. SQL injection, NoSQL injection, and there's just a ton of them. The problem is that you can't know all of them by heart, of course. So you'll just have to dive in and see which ones fall under this category to a degree. Improper asset management means just that I have an API running, but I have no idea how many APIs I have, what their IPs are. I'm just lost, and this can create ghost APIs, which might be a problem. Insufficient logging and monitoring, I say there should always be alerting there as well, because of course if you have monitoring, fine. If you have logging, fine. But if no bells go ringing when you get hacked, you're still fucked. So that's a little bit of a presentation. I can see already as well that we have quite a few ports open, or at least if we scroll all the way up there, there we go. We can see that we have quite a few ports open, but this isn't even everything yet. Now, how am I going to do a request to here? I'm just going to use the browser for now. I'm special, I can do that. And then I can see there's nothing found here. But what if I go to that API docs thing? Again, I can see some nice API docs. I wonder what could be on here. And then I can basically, for encode an image, apparently upload it here. Maybe there's other functionality that I haven't been able to explore yet either. Again, fuzzing, and I need to go through all of these ports like that because I don't really know what they are. FileMaker? What the hell are you? What the hell are you suggesting here, Nmap? That's apparently it's of course it's getting requested over SSL. There we go. We might have something more. API docs. Nothing in this case. Maybe something else. Who knows? There are also more ports open, of course, because I just did a fairly basic port scan for now. But it is important to know how to discover your targets and how to find vulnerabilities effectively. Thank you so much if you stuck around for this long, because that's my basic introduction to hacking APIs. I hope you enjoyed that. Let me see, there were some questions, I believe. I'm going to go to those now. It's 4 a.m. and holy crap. Yeah, please do it ethically and legally. I have to disclaim that always. Uganda, nice. Madrid, Brazil. You guys are from all over the world, and some of you guys are up on like 4 a.m. That's crazy. Now, what I haven't done yet is I haven't given out my next coupon yet, which is gonna be the XSS guide. Let's do that quickly. So I can go through all of your questions then, and you can jump on that XSS guide. For those that are confused, API, yes, indeed. Good job there, Emerald Wolf. Thank you for clarifying. Really appreciate that. Can you use the DOM to grab an API key because it is an object variable? That is a great question, Emerald Wolf. And what Emerald Wolf is basically asking is, when you have a website, you have your source code and you have your document object model, which is all around your source code, basically your return, for example. I am on studio.youtube.com now. I need to know where I go if I click this return button. That's my document object model. And he's asking, from that document object model, can I then grab an API key because it's in an object variable? I don't know out of the top of my head. I would think that maybe if you have some type of cross-site scripting available through DOM cross-site scripting, that might be an option. That's a good question. I'm gonna get back to you on that. Thanks. I really appreciate it, Emerald Wolf. Don't break the server. Yeah, guys, Orgus has been working on this server very hard. If you break it, just let him know. He loves hearing about how you can break the server. He just loves hearing about that stuff. Oh, and I need to. Oh, this one will be interesting. We have 3 seats for the API bootcamp. Who's gonna be first? Who's gonna be first? Fergs Buster and Go Buster, which one is faster? That is a great question. To be honest, for me, it doesn't matter all that much. It's not like I do so many scans that seconds are going to make a difference or even minutes, you know? I just run all of these things in parallel, but it is a good question. I might have to do a comparison video on that. Can't install Fuff, but you're using Parrot. Like, that's your problem. You're using Parrot. Parrot just sucks, dude. How to piss off a community in one sentence. Laughing my ass off. Yes, you do want to make Haggis happy. The guy, I don't know, because believe me, like last time I didn't make that guy happy. He was shagging 2 girls, and then I had 25 rats out of nowhere. Fuck's sake. Hey, please upload this video to YouTube. Of course, this will be uploaded for sure. Good question there. At Greenet, yes, you can use FUB for subdomains. Indeed. Oh, my text jumped there. I see now a better tool. I don't see limitations. Go bust to refer books. What I just honestly use for API actually is content discovery of Burp Suite. I just like it because it can do different things at the same time. It can do content discovery, meaning you can do file discovery, you can do directory discovery. The thing is, it can just not do parameter discovery at the same time, but it can do all of this shit recursively. So if it finds a directory, it can look for files in that directory. It's an awesome tool. Let's see. In real life, it's worth to check the API docs. The chance of having this slow it is definitely worth it, but you will have to fuss for it a bit. Fuss for it. Jesus Christ. Definitely, because the way you learn about this API is through API documentation, and it might not always be in this way. Sometimes you just have API documentation available. One of the things that I love to hack was no, not this one, Team Leader API docs. So as you can see, sometimes it's just like this as well. You have some normal API docs in which you will have to find your way. It's a little bit of a gamble, but this will be your very first step that you're always going to take. Good question, Black Crow. Let's see. Emerald Wolf says he wants to learn and try new things. Well, I have one more new thing for you guys, and you're gonna love that. This is an endless bundle, and I hope you guys have fun with it because this contains all of our current and future courses. Only one, though, only one. So be fast. Anyway, my friends, this was my little presentation so far on API hacking and API documentation. I would again like to remind you that our bootcamp is next week, and I'm going to lengthen the early bird. You can see that link right here. We're going to lengthen that early bird with just 2 more days. So if you do want a seat and you don't have one yet, I would recommend you get it as soon as possible. These do sell out rather quickly. So if you still want a seat, please do grab it. It's gonna be like this, but a lot better because we're gonna have a lot more time to talk and chat. If you have questions now, also please don't forget to ask. I would love to hear everything that you're still dealing with in terms of questions. It's important for me that you don't leave with too many unknowns here. Now, if you're not going to attend this boot camp, what I do want to give you is, at least through this session, is that you have a starting path, at least something to hold on to. There's more though. There's a lot more in our API bootcamp. You will see this as well. We're just going to go through a lot more SOAP versus REST, API authentication and authorization, your architectures, your documentation. I think it's important. Yes, indeed, Malware, we are back with our boot camps, and we appreciate all of the support that we get through them. It's amazing. It really is. We have gotten something for you this time that's, I think, better than ever, at least in my opinion, because I'm kind of sick of web. And yes, you heard me right. I'm sick of web. Why is that? Because I know that web is just a front. It's the same as, like I love web, don't get me wrong, to a degree, but it's the same as, for example, if I want to hack my car, I'm not going to hack the bodywork. I'm going to hack the freaking engine, aren't I? So, what am I going to hack when I want to hack the internet? The engine of the internet, which for me is APIs, for sure. Let's see, great presentation. Thank you so much, Black Crow. Really, really appreciate that. I hope you guys enjoy the courses. I hope you guys have a good night, and I hope you guys have a million bucks to show for it in the next stream. Please let me know of your successes. Tag me on Twitter. Let me know of your failures as well. It's important. I will let you know about mine. It's important that we keep each other up to date and realistic, very realistic, because we all fail. It's just a part of life. But the harder we fail, the bigger of a chance we have to make a comeback, in my opinion. Thank you so much, ladies and gentlemen. You have been awesome, and I would like to see you in the next one. Bye bye.